नहीं क्लास 10 को रावले
ఇప్పుడు చూడు సిగ్నల్స్ ఆన్ సిస్టమ్ వినబడుతుందా? ఇంకేమైనా అడ్జస్ట్ చేయాలా? ఎవరు పడతారు కానీ ఇంకా మొదలయ్యలేదు అప్పుడు హ్యాండ్స్ రైజింగ్ ఏంటి? Hello. Hello. Is it audible? Good evening, friends. How are you all? Hope you are staying at home and having very good health. Is it audible for everyone? Is it audible? Okay. Myself, I am ML Narasimham. I am going to teach signals and system subject for you. Before starting the subject, first let me discuss what syllabus we are going to cover in signals. What syllabus we are going to cover in signals and system. Let me discuss that. Visibility is good for everyone. Visibility is good. Okay. This subject is divided into three parts. One is analysis. Second part is approximation. Second part is approximation. And the last segment is the transformation. Analysis, approximation, transformation. In the analysis, we are learning the basics of the subject, that is introduction. We are learning the basics of the subject, that is introduction. Means what is the definition of signal, types of signals, how they are further classified, what are the different forms of systems we have. All that basics we are learning in first chapter, that is introduction. Second topic is linear time invariant system, LTI system, linear time invariant system. In this, mainly we are learning the word convolution. Why do we need this tool convolution? For a known input system, if you want to get the output, suppose we have given some input to CRO, it is showing the output graph for us. What is happening internal to the system, no one knows. That we are checking mathematically by using which tool? Convolution tool. So our basic concern in LTI system is towards this convolution, which is a simple mathematical tool. Then we are learning approximation, that is Fourier series. Of course, first we are learning continuous Fourier series. First we are learning continuous Fourier series. One is trigonometric Fourier series, the other one exponential Fourier series. Two forms of Fourier series representation, which is strictly valid for periodic signals. It is strictly valid for periodic signals. Then we are starting our first transform, that is continuous time Fourier transform, CTFT, first transform. Then we are going for Laplace. Then we are discussing discrete time Fourier transform, DTFT. Then we are discussing jet transform. Finally, the concept of DFT and FFT. DFT and FFT. Why do we require all these transforms? Means each topic has its own advantages and disadvantages. Like Fourier transform cannot be defined for certain unstable signals. Fourier transform cannot be defined for some unstable signals. In such cases, we are shifting to Laplace. Certain applications of Fourier transform also we are learning, like sampling theorem is one application in the case of CTFT. Autocorrelation, cross correlation is another application. Autocorrelation and cross correlation. With respect to jet transform, we are learning two forms of filters. One is FIR filter, the other one IAR filter. Finite impulse response, infinite impulse response. Two forms of filters we are. This is the syllabus we are going to cover. Regarding your doubts, whenever I give break, sometime I'll give. At the end of the session also, I'll give chance for you. So till that time, if you have any specific doubt, keep it aside. You can talk to me freely once I give the chance for you. Okay? Regarding weightage. For ECE as well as instrumentation student, average weight is 9 to 11 marks per gate. This year also around 11 marks the questions were asked. Average weightage in gate is 9 to 11 marks. Whereas IES, engineering services, or ESE, you can expect 8 to 10 objective questions. I'm speaking about objective, 8 to 10. Descriptive, IES descriptive, it is around 60 marks. 60 marks. All this syllabus is common for GATE exam, ISRO exam, but additional IES syllabus is there. Apart from these topics, additional IES topics are also there. That is speech, audio, radar, signal processing usages. What is an audio equalizer? speech, there are two types of sounds. All the basics we are going to learn in additional IES. This is exclusive for IES. But to understand the last topic, that is speech audio radar signal processing, you must be thorough with Z transform, DFT, FFT, the application oriented part. Otherwise, you will not understand anything. So my simple suggestion is to be thorough with signals. How I am going to teach is the basics of the subject we are developing in the first chapter, that is introduction. Entire subject basics we are going to develop where? In introduction. Like, for example, to say, we are learning here one concept called as energy and power signals. That concept is, of course, almost every year gate paper, there will be a definite model on that energy and power signal. That concept again we require in Fourier transform chapter. Periodicity is compulsory required in Fourier series. So whatever the basics we are developing in the first chapter, it will be very useful for the entire subject. So be thorough and be attentive in the class. Don't bother about the number of transforms we have. Our main transform is CTFT, continuous time Fourier transform. Once we are thorough with CTFT topic, continuous time Fourier transform, all are simply linked to one another. Most of you are aware. Laplace and Fourier transform, one simple link is S place J omega is the replacement. It's not that much simple. Certain conditions are there. So all other topics are interlinked. So after completion of every slide, for 30 seconds I will hold. If you want, you can take a snapshot for that. So this is the syllabus we are going to cover in signal subject. This is the syllabus we are going to cover in signal system. So we must be thorough with which topics mainly? Introduction topic and Fourier transform. Once you are thorough with Fourier transform, all other topics becomes very easy for you. They are very easy, but for that, what is the minimum requirement? We must be thorough with Fourier transform topic. Okay, CTFT we must be. Please take a snapshot. The syllabus which we are going to cover.
Dear students, wait for 5 minutes. Due to power loss, class has been hold for 5 minutes. Dear student, wait for 5 minutes. Due to power loss, class has been stopped for 5 minutes. Sorry for the inconvenience. Dear student, sorry for the inconvenience. Wait for 5 minutes. Due to power loss, class has been hold for 5 minutes. Dear student, wait for 5 minutes.
Hello. Hello, everyone. Then I'm audible, sir. Sorry, suddenly power has disconnected because there is rain today. Sorry. Where we are connected now? Yes, sir. Okay. Can I start now? Sorry for the inconvenience caused. So this is the syllabus we are going to cover in signals. Okay. Reference books. Which books to be followed for signals? Standard book of signals and system is standard books. Signals and System by Oppenheim and Nawab. It is a standard textbook on signals. Any new fellow is writing a book on signals, means definitely they will copy from this book. It's like reference for everyone. It's an excellent book to learn. But the problem is it will take so much time for understanding the concepts mentioned by Oppenheim and Nawab. Another easy book, we have same title, Simon Hakins and Van Ween. Same fellow who has written Communication System, Simon Hakins, and that is also one of the good book we have. Who has written Communication System. Almost they have given Oppenheim now only by changing number game. Problems slightly different. But according to me, if you want to study signals and system like a novel, easy presentation, analog and digital signal processing, analog and digital signal processing by Ashok Ambardar. It is available from Cengage Learning Publications. It is one of the extraordinary textbook I have seen. The beauty of this book is he will explain the concept for 2-3 pages. He will make a review panel. In Smartfor, we have learned the topic, review panel. So 30% of my discussion in different chapters, whatever the syllabus I mentioned, 30% of my discussion is from this book. Analog and Digital Signal Processing by Ashok Ambardar. The problem is it is not available in the market. Go to this site, scribd.com. How much easy presentation is there once you download from the book, download the book from the site, you are going to understand. Script.com site, it is available. Analog and Digital Signal Processing. Same author with modern and DSP, another title is available, but in the few topics are Hello? 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 God must be crazy. Today only it is happening. Just now we started. In 10 minutes, there are 2 breaks. So probably signal is interfered. Some other thing. I'm really sorry. Okay. Let me continue. These are the reference books. Especially this book, Ashok Ambardkar. It is like a Chetan Bhagat novel. Very easy presentation. Very easily you can understand that book. Please try to download that. It is available in that site, script.com. Okay. These are the reference books. Be confident on me in the sense my discussion. I'm saying 100% that models will appear in competitive exams because we are going to learn the best models of signals in the class. Apart from theory, the problems also. Apart from theory, the models also. Let me start the subject. What is a signal? Signal means what? Everybody will say anything that carries information is signal. Generally, everybody will say anything that carries information is a signal. What is the meaning of this word information? What is the meaning of this word information? Whatever we know, generally it is not. Whatever we know, generally it is not treated as information. So one of my friend is asking for previous slide. Yeah, this is the first slide, friend. I hope you have taken snapshot for that. You asked me some time, but in the meanwhile, power is corrected. This is the second slide. This is the second slide, reference books. Third slide, just now I started. So what is information means randomness. Whatever we don't know, it carries some information. One simple example to say f of t equals to sin t. Here the independent variable is the time. Most of us know how to draw this function. So generally, it doesn't carry any information. Most of us know how to draw it. It doesn't carry any information. But if you take another example like ECG signal, electrocardiogram. Why we require ECG signal? To measure the heart patient beat, generally doctor is going to observe this waveform. On the y-axis, we are checking the amplitude of the heartbeat as the time progresses. On the y-axis, we are checking the amplitude of the heartbeat as time progresses. Roughly, we are going to check the waveform, something like this. Roughly, it's not exact waveform. So this waveform is random for us. We are not in a position to understand this waveform. The reason is we are not doctors. Only doctor will understand this graph. But scientific curve, every one of us know how to draw it. So wherever randomness is there, it is carrying some information for us. If randomness is more, information content is more. Randomness increases means what increases? Information increases. Randomness increases means information content increases. So everyone will say anything that carries information is signal. We are speaking, that is a signal. You are listening, that is a signal. But whatever we don't know, from that we are carrying some information, means randomness increases. If randomness increases, what increases? Signal content increases. For your understanding purpose, let me explain with a simple mathematical formula. Normally in communication, we are learning that the information in a discrete event is given by relation logarithm of 1 by pi base 2. Entropy at that place we are learning information a discrete event is given by logarithm of 1 by pi. Suppose we are assuming probability as 1 by 8. How many information bits are needed for us? Substitute there, 3 bits are sufficient. But if you select the probability like 1 by 32, then what is the number of bits? Come on, sir. It will be 5 bits. Out of the two considered probabilities, where the randomness is more, out of the two considered probabilities here, where the randomness is more, second case randomness has increased. Out of 32 outcomes, only one is it. But in the first case, out of 8 outcomes, only one is it. Second case, randomness has increased. What happens to the number of bits? There is increase in the number of bits. So if randomness increases, information content increases. Something that happens randomly will provide definitely more information. Of course, one real-time example nowadays is happening. Corona, no one has expected before 6 months, but suddenly it happened. Randomly, it is gone increasing. So we are getting some information. So we should behave like this. We should be in a proper manner, regularly washing our hands. So wherever randomness is more, automatically information content is. So signal means it carries information. What is the meaning of information is whatever we don't know that is happening randomly, it carries more information. Randomness increases means what increases for us? Information content increases. It is the first characteristic of signal. First characteristic of signal. Second characteristic is signal can be represented as function of one or more independent variable. Signal can be represented as a function of one or more independent variables. Independent variables. What does it mean? How signal is multivariable? If you consider our normal voice signal, speech signal, it is only one-dimensional because the independent variable is time. When we are speaking with other person, what is a coordinate that is continuously changing? Only time varies. Whatever we are speaking is amplitude of the spoken word, that is a dependent variable. Signal means information. Information indirectly means what? Randomness increases information. Again, you want spelling of information. Signal, anything that carries information is signal. What is information? How to understand that what information means? If randomness increases, information increases. That is what mathematically I explained from this example. Out of these two probabilities we considered, second case randomness increased, number of bits are increased. Whatever we don't know, from that we are extracting some information. Whatever we know, generally it doesn't carry any information. So the first characteristic of signal is randomness. Second characteristic, now we are observing signal can be represented as function of one or more independent variables. Normal voice signal is one-dimensional because the independent variable is time. When you speak with other person, the coordinate that is varied continuously is time. Y-axis is the amplitude of the spoken word, that is a dependent variable. Whereas if you take an image signal, it is a two-dimensional because any image signal is taken as a combination of pixels which that is represented like picture element. In shortcut we are saying that as what? Pixel. Here the intensity or brightness can be varied with respect to two spatial coordinates. Either you can vary horizontally or we can vary vertically. Two spatial coordinates we are considering. So image is two-dimensional. Here we are checking the examples of multivariables. When you take normal TV picture, TV signal, it is considered to be three-dimensional because here the intensity or brightness can be varied with respect to what? Two spatial and one time coordinate. What is generally TV signal? Capturing different images for different instants of time. Image has already two coordinates. What is the extra coordinate for us? Time is the. So this is the second characteristic of signal. Signal can be represented as function of one or more independent variables. But in our discussion, we are not discussing any multivariable. Always on the x-axis, we may change time or we may change frequency. We are not discussing any two-dimensional or three-dimensional signals here. Hello? We are not discussing any two-dimensional or three-dimensional signal here. Always we are varying one independent variable, that is it may be time or it may be frequency. It may be time or it may be frequency. One more characteristic of signal is bandwidth. Generally, bandwidth means we are giving a definition that it is the range of frequency over which gain is constant. It is the range of frequency over which gain is constant. Hello? Is it audible now? Whether I am audible now? Some of you are saying. Okay, some of you are saying maybe problem is from your side. Please cross check, sir. Most of them are saying yes. So the third characteristic of signal is bandwidth. When you take audio signal or voice signal, first let me give example of audio. General range is what? 20 Hz to 20 kilohertz we are. Voice signal intelligibility is within the range 300 Hz to 3400 intelligibility. Like that AM signal, FM signal, every signal will have some specific frequency band. So it must be one of the characteristic of signal. Must be one of the characteristic of. So whenever these 3 points are satisfied, we can say signal is a signal. What is the first characteristic of signal? If randomness increases, what increases for us? Information content increases. If randomness increases, information content increases. Second characteristic is we can vary more than one independent variable. We can vary more than one independent variable, but in our discussion, we are taking only one independent variable. That is, either we are changing time or it may be frequency. We are changing either time or frequency. The last characteristic of signal is bandwidth. Every standard signal will have some band of frequencies, depends on the context, whether it is signal bandwidth or system bandwidth. If the 3 points are satisfied, then we can say signal is a signal. Those who want to take snapshot, our previous slide, I'm giving some time. So anything that carries information is signal. Simple way of defining it. Anything that carries information is signal. This is the next slide. 3 characteristics we discussed. One is randomness. The other one more than one independent variable. Last one is bandwidth. That is the definition of signal. But why we are studying signals system? What is the purpose of learning this subject? We can't say because it is there in the BTech syllabus or for competitive exams. There must be a reason. What is the reason? We cannot transmit a signal from one place to another place without in-between disturbances. You cannot transmit a signal from one place to another place without in-between disturbance. So before transmitting and receiving any signal, we have to make some changes. One is enhancing. Second step is extracting. Third step is storing. Final step is filtering. Before transmitting and receiving any signal, these are the mathematical changes we are making. Enhancing means amplifying the signal strength. Generally, we are using different types of power amplifiers, amplifying the signal strength. Extract means pick the signal. Till now, I use a microphone. Of course, now I am using directly. Our voice signal can be captured by using this microphone. Store the information at certain point. Why you want to store the information? To do the analysis later on. Of course, you are habituated this from few days. For few days, whatever the classroom went on, the records are available for you. So we have to store the information for a particular purpose. What is that purpose? We want to observe one more time. What is that information? So for storage, generally the device we are using is inside the computer or laptop, we are storing the data. Finally, perform filtering to suppress the noise content of the signal. Some background noise may be added. To suppress that, we have to do it. Each mathematical step here represents a black box, which is a system. Enhancing means amplifying the signal strength. Enhancing means amplifying the signals. Extract means pick the signal, capture it. Pick the signal. Store the information at certain point if you want to do analysis later on. If you want to do analysis later on, store the information. Finally, perform filtering to suppress the noise content of the signal. So before transmitting and receiving any signal, These are the general changes we are making. Each mathematical step here represents a black box. That is what we are calling as system. Subject name is signals and system. So before transmitting and receiving any signal, these are the general changes we are making for a signal. Correct or not? So what we learned till now, signal means information. What are the characteristics of signal? Randomness or uncertainty. Randomness increases means what increases? Information content increases. Second characteristic is more than one independent variable. More than one independent variable is the second characteristic of signal. Correct or not? More than one independent variable. Last characteristic is bandwidth. Last characteristic is bandwidth. So before transmitting and receiving any signal, what type of changes we want to make? These are the four changes: enhancing, extracting, storing, filtering. Correct or not? Extract means pick the signal. How to pick the signal? For storing purpose. By using this microphone, we can pick the signal such that without background noise, more audibility may be there. More audibility may be there. All your doubts, wait for some time. Let me explain. Whatever I write, if you ask me immediately, I cannot respond because others will get disturbed. I'll explain. Wait for some time. The break time, I'll do a better explanation for you. Okay? So signal definition is over. Now let us discuss the types of signals we have. What are the types of signals we are having? Generally, there are three forms of signals. One is named as continuous signal, also called as analog signal. Continuous signal, also called as. The second form is the discrete signal. Third form is the digital signal. There are three forms of signals: continuous, analog, discrete, digital. Strict sense, there are four forms of signals. Discrete to digital approximation, we are taking a waveform that is quantized signal, staircase type. In the strict sense, there are four forms of signals: continuous signal, discrete signal, quantized signal, digital signal. Why there are four types of signals means, for any type of signal, on the y-axis, we may change amplitude for any type of signal. On the x-axis, what we are changing? Time. This amplitude may be continuous or discrete. Time may be continuous or discrete. Amplitude may be continuous or discrete. Time may be continuous or discrete. Amplitude may be continuous or discrete. Time may be continuous or discrete. Total, how many combinations are there? It can form four forms of signals or not. That is what these four types. Based on the amplitude and time, they come into. What is the definition of continuous signal? What is the definition of continuous signal? Signal means flow of information. Continuous signal means continuous flow of information. Continuous flow of information. It occurs for continuum values of time. It occurs for continuum values of time. It means as time is varied from minus infinity to plus infinity, every instant we know the amplitude of the signal. As time is varied from minus infinity to plus infinity, at every instant the amplitude is known. Okay. It occurs for continuum values of time. Best example is our voice signal only. When we are speaking, there is continuous flow of words. When we are speaking, there is continuous flow of words. The other way to say the definition with respect to y-axis and x-axis, a signal which is continuous both in time and amplitude. It is continuous in time as well as continuous in amplitude. That is treated as continuous signal. A signal which is continuous both in time and amplitude. Let me give an example here for continuous signal. Suppose we consider e power minus 2t u of t Any signal multiplied by unit step function means, what does it mean? The signal exists only for which time? Positive time. And it is acting like a decaying exponential, or it is acting like a decaying. From 0 to infinity, you select any instant. We know the amplitude of the signal. Suppose you wanted 0.5. What we'll do? T place 0.5. E power minus 2 into 0.5 means E inverse. If you wanted 3, what is the amplitude at 3? E power minus 2 into 3. E power minus. From 0 to infinity, you select any instant. We know the amplitude of the signal or not. It's a time axis is continuous. The respective amplitude is also continuous. Time is continuous. Amplitude is. Whereas, suppose we have chosen this signal. Suppose we have chosen this signal. Now you tell me, what is the amplitude of this signal at t equals to 1? We can't say. There is a jump in the amplitude from 1 to 2. Similarly, at 2 also there is a drop in the amplitude from 2 to. So at 0 also there is a jump in the amplitude level. Correct or not? Means it is discontinuous at that instant. Y of t signal is discontinuous at that instant. At 0, 1, 2. Wherever there is a sudden jump. So this type of signals are called as piecewise or discontinuous signal. Piecewise or discontinuous signal. So whatever I have shown in red mark here, at that jumps have occurred. At that instant, the amplitude of the signal is not defined. One well-known example for everyone. One well-known example for everyone here is step function, unit step function. U of t also has a jump at origin. Amplitude rises from 0 to 1. Okay. So for the signal y of t, why the word piecewise? For different intervals, its amplitude is different. 0 to 1 interval, what is its amplitude? 1. 1 to 2, what is the amplitude? 2. So wherever there exists a positive jump or negative jump, wherever there exists a positive jump or negative jump, at that instance, amplitude is not defined. So most of the books, they will show the same graph, something like this. They will show the jump location as point of discontinuity to show change in amplitude has occurred. Okay. If you look at y of t, at 0.5, its amplitude is 1, continuous only. At 1.6, its amplitude is 2, it is continuous only. What are the jump instants here? At 0, 1, 2, the amplitude is not defined. So basic difference between the word discontinuous signal and continuous signal is what? They are one and same except at which locations? Except at the jump locations. They are one and same except at which locations? Except at the jump locations. Okay. So what is the definition of continuous signal? It occurs for continuum values of time. Both y-axis and x-axis, they are continuous in amplitude. Why the word analog? Most of you have heard the word analogous. Analogous meaning is what? Similarity. In shortcut, we are saying LOG. Analogous means similarity. Analogous means, in what way they are similar? If you look at here, the y-axis and x-axis have the same property. What property? Both are continuous variables or not? Y-axis is blindly following the characteristic of x-axis. What characteristic? Both are continuous variables. That is the reason continuous signal can be also called as analog signal. Analogous means similar. Analogous means they are interchangeable words. Continuous signal or analog signal, the meaning is one. So I hope you got clarity of discontinuous signal and continuous signal. At the point of jump location, amplitude is not defined. Some fellows will take average value with the reason. Let me explain under step function. Okay, there is a reason. We cannot take blindly. Okay, wherever there exists a jump location, at that instant amplitude is not defined. When you have continuous signal, what is the need for second form of signal? When you have a continuous signal, what is the need for discrete signal? Why we require it? Why we require a discrete signal? Before that, what is the definition of discrete signal? What is the definition? It is continuous in amplitude but discrete in time. Continuous in amplitude but discrete in. It means the signal is checked for certain instants, not everywhere. Integer values of time index. It is continuous in amplitude but discrete in time. The fundamental reason we require a discrete signal is there are two reasons. If you want to store the data inside our computer, computer can understand only ones and zeros. It will not understand the continuous information. So it must be converted to a convenient form. It must be converted to a convenient form. So we are converting first continuous to discrete or sample form. Another advantage of discrete signal is the concept of multiplexing becomes very easy for us. What is multiplexing? Multiple signals through single channel. You are aware in digital 4x1 mux, 8x1 mux like that. We can transmit multiple signals through single channel. Best example, our FM radio station. 88 to 108 megahertz with 200 kilohertz width, we can accommodate at least 100 radio stations. What are the regular radio station frequencies? 91.1, 92.7 megahertz. When you tune to that frequency, we are in a position to listen or not. How the multiplexing becomes very easy when you go for a discrete signal. Let me explain with an example. Before that, how we are getting a discrete signal. How we are getting the discrete signal. I hope you have taken snapshot for this. I will wait for a few seconds. Difference in continuous and discontinuous signal. Difference in continuous and discontinuous signal. In the process of converting a continuous signal to, in the process of converting continuous signal to discrete signal, we are using a device that is named as a sampler. If x of t is the continuous signal we have, how to retain its discrete form is t is replaced as n into ts, where n is any integer value. Ts denotes the sampling time. Why Ts comes into picture means we don't want always uniform separation of one unit. Certain time we want to select the signal with a gap of 2 seconds, 5 seconds, 10 seconds. That is decided by which parameter. Okay. So in the process of converting continuous signal to discrete signal, we are using a simple switch that is called as sampler. What is sampler? Like electronic switch, on and off. If you want to select the amplitude of the signal, close it. If you don't want to select, open it. It is acting like an electronic switch. Sampler, simple manner to say it is an electronic switch. Let me tell you, for this decaying exponential only, what is the discrete equivalent? I am taking this example. For this decaying exponential only, what is the discrete equivalent? So x of t we selected as e power minus 2t ut. So what is the discrete form of that one? So to convert continuous to discrete, what is the mathematical change we are making? T is replaced as NTS. For my convenience, I am assuming sampling time as 1 second. Such that what will happen to the discrete signal expression? E power minus 2n u of. Actually, t is replaced as n into ts, but we are fixing ts as 1 second. As n is integer, try to select at certain discrete instance as n is, and try to check the original continuous signal only at that discrete instance. Try to check the original continuous signal only at that discrete instance. Okay. At 0, what is the amplitude of continuous signal we are having? At 0, what is its amplitude? 1. Draw a line of amplitude 1. At t equals to 1, what is the amplitude for original analog signal? E power minus 2. At 2, it becomes how much? Substitute here t plus 2. It becomes e power. Like that, the respective discrete signal is retained. Like that, the respective discrete signal is retained only at integer instance. Don't have a wrong thought. X of n signal is not defined for non-integer values. Between 0 to 1 also it is defined, but what gap we have provided here? Sampling time we assumed as 1 second. Suppose we have taken TS as 0.5. 0.5. N number is multiple of 0.5. Then the spacing will be 0 into 0.5, 1 into 0.5, 2 into 0.5. It is incorrect to think that discrete signal is not defined for non-integer value. It is defined, but we don't require the data because for transmitting the signal, this amount of information is sufficient. For transmitting that signal, this amount of information is sufficient. So what is the basic difference between continuous signal and discrete signal from the graph? They are maintaining same amplitude. Here time axis continuous. Here time axis is looking like discrete. Only integer samples are not. So what is the easiest way of differentiating continuous and discrete signal is wherever you are going to observe the pinpoint shape, wherever you are going to observe the pinpoint shape that is looking like discrete signal, otherwise it is continuous, or lollipop form. Lollipop form is discrete signal, otherwise it is treated as continuous signal. Of course, we are not in a position to convert every continuous signal directly to discrete signal. Most of you are aware. We should obey which condition? Sampling theorem condition. What is that? Sampling rate must be greater than or equals to 2 times highest analog frequency. That is the condition or not? We are not in a position to directly convert every continuous signal to discrete signal. Correct or not? So in the process of converting continuous signal to discrete signal, in the process of converting continuous signal to discrete signal, we can take both positive and negative values here. What is my example? I have taken positive length. If you take negative side also we can take. According to the example I am saying, n can be negative also. I mentioned here 0 plus or minus 1 plus or minus 2 like that. Regarding these slides, if you want to take snapshot, I will use in the last minute each slide for 30 seconds. So don't continuously waste your time for that. Okay. In the ending, I will give chance. Okay. It is my request. In the ending, I will give chance to take snapshots of them. Each slide for 20 to 30 seconds, I will give chance for you. Okay. So to convert continuous to discrete signal, what is the device we are using? Sampler. By using a sampler, we are in a position to convert continuous to discrete. And don't have this wrong thought. Discrete signal is not possible in between. It is also defined, but we don't require the data because for transmitting the signal, this amount of information is sufficient. How I am saying that? For transmitting the signal, this amount of information is sufficient. Let me give one practical example. If I say a word should, after uttering that word, I want to check the graph of that word. In English, we have 42 phonemes. I am not teaching English signals only for graph I am saying. Any word is combination of phonemes like this. Any word is combination of. If you try to draw the graph of SH, fish, roughly that is a continuous waveform we are going to observe. Roughly, it's not exact. What is the sample form of this one, sir? We are checking with what gap? We are checking that signal with what gap? TS units or not? We are checking signal with TS units gap. What are the amplitude levels? The red dots I am showing here. What are the amplitude levels of the beginning 4 or 5 samples? Red dots. Observe here. Everyone, observe here. 4 to 5 samples, approximately they have same amplitude level or not. It means it is not showing much variation for us. So why to waste our channel width by transmitting same information? For example, to say every cell phone company is paying crores of rupees to government of India. Why they will waste their money? Why they will waste their money by transmitting same information continuously? After capturing the data, unnecessary things are. Suppose a TV fellow has done recording for us. Sorry. A TV fellow has done recording for us. So, if he has done recording for 3 hours, all 3 hours he will not show for us. That is minimized as a 30 minutes program. So in live recording also with certain amount of delay, they will transmit the signal. So the unnecessary data will be removed. So wherever the amplitudes are approximately equal, they will discard that samples, try to transmit the next sample where it is showing some variation in the amplitude level. How the discarding samples are done, that is what the technique. After some time we are learning decimation and interpolation. If you want to reduce the number of samples, we need a decimator. If you want to increase the number of samples, we need a interpolator. By that way, if the number of samples are decreased here, if the number of samples are decreased, signal width is decreased, channel width can be used for more number of signals. That is what multiplex. Once the number of samples are decreased, channel width is increased. The channel width can be used for multiple signals. That is what multi. What I said. When we take a discrete signal, the concept of multiplexing becomes very easy. From this example, roughly you can understand. If you remove the redundant samples, redundant means even if you discard the samples, no loss of information. Once the number of samples of the signal is decreased, signal width is decreased, means channel width can be used for more number of signals. So there are two reasons why do we require a discrete signal. One reason is what? Storage purpose. To convert continuous signal to discrete signal. To convert continuous signal to discrete signal, we need a device that is sampler. Okay. As well as to transmit multiple signals by reducing the signal width through our channel width also we require. Some fellows will say discrete signal also as the sampled signal. Some fellows will also say discrete signal as sampled. One more point I want to clarify. One more point I want to clarify is every discrete signal is not sampled form of continuous signal. Every discrete signal is not sampled form of continuous signal. It means we can have predefined discrete signals. I am giving a general example. Suppose you want to observe temperature versus time graph in a particular area, particular temperature versus time. Okay. Assume we are taking the reading for every 1 hour. Assume we are taking the reading for every 1 hour. There may be rise or drop in the temperature, but it is continuously changing, which is discrete form or not. We have not done any sampling. We have not done any sampling. One more example, most of you love it. Suppose we are watching cricket match. What is the average number of runs that are scored in every over? We are going to observe a bar graph like this or not? The average number of runs that are scored in every over. It is also in which form? Discrete form. Right or not? So don't have a wrong thought. Whenever we require a discrete signal, sampling is compulsory. Sampling is needed for what purpose, sir? Multiplexing. Sampling is needed for, we can have predefined discrete signals. Example like this, temperature versus time, number of runs scored in every over. Best example is, on the y-axis, take our percentage of marks or CGPA. Every year, BTech first year, second year, third year, fourth year, roughly you draw the graph. That is discrete form. Correct or not? So there is no need that whenever you want to get a discrete signal, we have to do sampling. Sampling is needed for what purpose? Multiplexing. Okay. Sampling is needed for multiplexing. Then what is the definition of digital signal? A signal which is discrete both in time and amplitude. A signal which is discrete both in time and amplitude is a digital signal. In the strict sense, it is discrete in time but quantized in amplitude. It is discrete in time but quantized in amplitude. What is a quantizer? Quantizer will convert continuous amplitude level to discrete amplitude level. Assume at a particular sample we have 5.6 volts. At a particular sample we picked, we have 5.6 volts as the continuous amplitude. What is the truncated number here? 5 volts. What is the round off number? 6 volts. Converting non-integer to integer. Converting non-integer to. By this process, we are losing some information. That is what you have learned as quantization as well. In PCM, it is a regular word, pulse code modulation. To reduce that problem, we are increasing the number of levels or not. For most of you, those who have learned communication subject, you have an idea on this point. To reduce the quantization error, we are increasing the number of levels. What sampler has done for us? Previously, we used sampler. Sampler is converting continuous time to discrete time. Time conversion means what we need. We need sampler. Amplitude conversion means what we need. Amplitude conversion means what we need. Quantizer is needed. That is what sample and hold circuit in simple manner. That is what. Anyway, digital signal I am not giving more significance because that is purely digital communication. Even whatever the signal processing we are learning is discrete time signal processing only. So till now in our discussion, even we discussed 3 forms of signals. There are 2 only which we are using regularly. What are they? One is continuous signal, also called as analog signal. What is continuous signal meaning? You select any instant, the amplitude is known. That is continuous signal. What is the definition of discrete signal? Only at certain instants amplitude is known means that is treated as discrete signal. If you take x of t, y of t, z of t, that is like continuous signal. X of n, y of n, z of n, that is like discrete signal. Yes, n should be integer only. In the x-axis, n should be integer value only. Discrete case. So the block diagram of signal processing system, whatever the discussion went on now, the block diagram of signal processing system is what? Simple way. First, we need an A to D converter. We are processing the continuous signal through A to D converter. What it will do? All the types of signals conversion, continuous to discrete, quantized, digital. Then it is processed through a DSP processor. That is application specific IC. What is DSP processor? Our computer is also a DSP processor. Finally, it is given to a D2A converter. What we are reproducing continuously. So either you transmit audio data or video data outside market. Our job is design of 3 ICs: A to D converter, DSP processor, D2A converter. So that is what we are learning: flash type, comparator, A to D, here R2R, ladder, DAC, like in analog subject. DSP processor, in the sense, depending on our requirement, it may be an IAR filter or FIR filter that we are learning as application topic in JetMaster. DSP processor. Either you transmit audio data or video data, whatever it may be. Outside company's target is design of these 3 ICs mainly. An easy example, when you are listening to music by using CD player, on the CD player, music is stored in the form of logic 1, logic 0. Technically, they are called as pits and lags. We are listening that ones and zeros are continuous information. So whatever we are processing, whatever we are transmitting and receiving is continuous. Middle world is discrete and digital. Of course, there are certain limitations for it. This system also, there are certain limitations. What are they? Its first limitation is sampling rate. Whatever the sampling rate you want to take for A to D converter, we cannot select. It is always decided by what? Highest analog frequency of the continuous signal. Blindly, you cannot choose whatever the sampling rate you want. It is always decided by highest analog frequency. Second disadvantage is, if you feel flash type is the fastest one, flash type A to D converter is the fastest one, I'm giving some general examples. Why do we require DSP? To transmit n bits, most of you are aware you require 2 power n minus 1 comparators. Each comparator is generally a 741 IC or not. Each comparator is 741. Generally, for audio transmission, minimum we need 8 bits. In the case of video, we are going for 12 bits. In the case of video, 12 bits. As the number of bits are increased, number of comparators are increased, indirectly the cost of the IC increases or not. This problem is there in the initial days. Nowadays, we are using nanotechnology. Because of which there is reduction in the size. Cost is not a concern nowadays because everyone wants the best quality. Correct or not? One easy example, when we want to listen the music, our grandfather time, we used to have a gramophone recorder or not. Gramophone, pipe colored structure is there, some pen recorder is rotating on that. If some dust is there on that, we will not get quality of this. Nowadays, we are using USB port or iPad, very simple thing, where we can store more information. And main advantage of digital systems are they are compatible and reprogrammable. Compatible means you are in a position to carry the equipment from one place to another place easily. Reprogrammable means same processor can be used for multiple applications. It is not the case with NLR. Not the case with. So whatever we are transmitting is continuous, receiving is also continuous. Middle word is discrete and digital, where we are making all these changes. In my discussion till now, we should remember two things. What is definition of continuous signal? You also say with me, of course, it is not audible. Continuous signal means at any instant the amplitude is known, means that is treated as continuous signal, represented like x of t, y of t, z of t, like that. What is discrete signal? Only at certain instants the amplitude is defined, means that is taken as discrete signal. Only at certain instants the amplitude is defined. So till now what we observed is what is the definition of the signal, then the characteristics of signal, then we observed the types of signals: continuous, discrete, quantized, digital. Quantized digital I am not giving more consideration because it is communication related. Whatever is required, that explanation I will give. Continuous signal, discrete signal. Only two forms of signals we are using in our subject: continuous signal or discrete signal. DSP means digital signal processing here. What is DSP means? Role of DSP, this is the first class, don't be tensed. So many practical examples I will give. Don't be tensed. First class only, that much emotion is not needed. Okay? General examples I have given. Once I come to jet transform, you will aware. How many practical examples I will give, you will know in jet transformer under convolution. Convolution problems when I am solving, you will have a better idea. Okay? First class. Okay? Don't be tense. I'll give good amount of examples. So till now, we observed the definition of signal, its characteristics and the types of the signals. What are the standard test signals we have? Either signal may be continuous or discrete. They are classified like energy, power, periodic, non-periodic. That is further classification. Before that, first we have to check. What are the standard test signals we are using. So our next topic is what? Standard signals, which are named as the predefined signal. Each signal has a specific application. Why they are called as standard signals? Each signal has a specific meaning. A to D converter, analog to digital ADC. DAC means digital to analog converter. ADC, analog to digital converter. DAC, digital to analog converter. One of my friend is asking what is DAC means. DSP, digital signal processor. Digital signal processor. Okay. The first standard signal which we are considering is named as unit step function. Unit step function, represented as U of t. That is the first standard. So how to define U of t mathematically? 1 for t greater than 0, 0 for t less than. Unit means amplitude is 1. What is the value at origin? U of t is discontinuous at origin. So strict sense, amplitude is not. But mathematically, we are taking average value. Mathematically, we are taking 1 plus 0 by 2, that is 1 by 2. There is a reason why we are taking this number. Wait for at least half an hour, don't be tense. Under signum function, I'll give that explanation. Okay. Average value 1 plus 0 by 2. 1 by 2 we have taken mathematically. There is a reason for that, why we have chosen that number. So where we can use this type of signal? Best and easy example is start of any automobile. Suppose we want to start our vehicle. Before start of the vehicle, it is in which position? Pressed position. Amplitude 0. Amplitude 0. After putting the key in the ignition button, when you press start, vehicle will start. Of course, it is not 1 volt. Certain power supply will be there. So starting of any vehicle means indirectly we are applying step function of some amplitude of that. Starting of any vehicle means indirectly we are applying step function of certain amplitude level. Okay. Why step function is taken as a standard signal means to check the transient behavior of any system, we are applying UT as input. When you apply a discontinuous input to a system, what will happen to the output behavior? When you apply a discontinuous input to a system, what will happen to the output behavior? That is what in controls also we are learning under time domain analysis. When you apply U of t to a second order system, what is a rise time, peak time, settling time, like that, some parameters we are learning or not. To check the transient behavior of a system, we are applying UT as. Its second advantage is it has a bounded amplitude. Be careful. I am using the word bounded amplitude. Even the signal is infinite length. What is the maximum amplitude of step function? 1. So where we require this boundedness, whenever we are checking the word stability, time domain, bounded input, bounded output, there blindly we can apply U of t as input. There blindly we can apply U of t as input. Okay. So one application is we can check the transient behavior. Another application is it has finite amplitude level. It has finite amplitude level. Unit step function means amplitude 1. General step function can have any amplitude level. General step function can have any amplitude. That is the first signal we have. Second standard signal which we are taking here is named as a rectangular function. Its other name is gate function. Rectangular function, other name is. It is represented as a rect of t by t, that is one symbol, or a times pi of t by t. Rectangular function, other name gate function, a rect of t by t or a times pi of t by t. So it is a finite length signal. Finite length signal having width of t units with amplitude a. Amplitude. So simply you can say x of t is what? A for what interval? Minus t by 2 less than t less than by 2, 0 elsewhere. It is a finite length signal which extends from minus t by 2 to t. Everyone can recognize it is looking like a symmetrical signal or not. Exactly at plus or minus t by 2, what is the amplitude? Again, they are discontinuous. Exactly at plus or minus t by 2, there the signal is discontinuous or not. So what is the significance of this rectangular pulse means? Ideal form of impulse is not possible. So the practical way of generating impulse is rectangular. Second advantage is when we are learning communication, we are using different forms of coding, return to 0, non-return to 0. Logic 1, logic 0 always represented by what? Rectangular pulse. Return on-off signaling. So you will know the significance of this rectangular pulse in the Fourier transform. 90% of our discussion is only on this signal. Rectangle in one domain becomes SAP function or sync function in other domain. Some of you may aware. Okay. Why this pi symbol is used means, if you do slight extension here, its appearance is like pi symbol or not. So different others follow different notation. We must be familiar. A rect t by t is one notation. Another notation is a of pi. A times phi of t by capital T. Okay. So the first standard signal we have learned is what? Unit step function. Second standard signal is rectangular or gate function. A rect t by t or A times phi of having width of t units, which is looking like symmetrical function and with respect to y-axis. With respect to y-axis, both halves are same. Correct or not? I will wait for a few seconds. Yes, rectangle is an even signal. With respect to y-axis, both halves are same. With respect to this axis, this side, both are same. You fold that. If you take flipped version of that one, again the answer is same. I'll come one by one. After completion of standard signals, then when we are discussing the classification, that will come into picture. Well, the third standard signal which we are learning is continuous impulse. Continuous. Its other name is Dirac delta. Continuous impulse, also called as Dirac delta function, represented as del of t. Represented as what is a mathematical way of defining del of t means? What is the mathematical way of defining del of t is? It is infinity at 0 for all other values of time it is 0. It is infinity at 0 for all other values of time it is 0. Is it possible for us to generate this signal practically? Impulse function. Anything that happens suddenly is an impulse. Anything that happens suddenly is an impulse. If you drop your pen, suddenly something that is an impulse signal. A point source, a point charge, even a thunderstorm. Thunderstorm, when it comes, it will come with a big sound. Correct or not? Thunderstorm, when it comes, it will come with a big sound. That is impulse. Anything that happens suddenly is treated as impulse. Practically, we cannot observe the type of signal. A signal that is occurring for nullified time having more amplitude well meaningless. But because of the mathematical properties of impulse, we can make our subject simple because of the mathematical properties of impulse. So what is the correct way of giving this impulse definition is, it is used as approximation of standard signals. It is used as approximation of standard signals.
Dear student, wait for 5 minutes. Dear student, wait for 5 minutes.
Hello.
Sir, అది కొద్దిగా side లో ఉండండి సార్. Dear students, sorry for the inconvenience. Due to heavy rain, power fluctuations is going on. Sir will relog in 5 minutes. Dear students, heavy rain in Hyderabad. There are power fluctuations. Sir will relog in 5 minutes. Sorry for the inconvenience.
Hello, friends. Whether I'm audible? Hello. Okay, today is a testing time. I'm really sorry. What is happening also? But so many days, nothing is there. Only today is testing time. Wonder. Anyway, we started defining the third signal del t, continuous impulse. Del of t is having infinite amplitude at origin. For all other values of time, it is 0. Why we are using impulse means because of its mathematical properties. So it is used as approximation of some standard signals. One easy example to consider. If we take a unit area rectangular pulse, we are fixing the area as 1 to generate unit impulse. We are fixing the area as 1 to generate unit impulse. If you want area of 5 units, we can take, no problem. Go on, compress the time axis. Go on, compress the time axis, but try to maintain same area. If I reduce the width from minus 1/4 to 1/4, 2 into 1/2 becomes 1. Further compression, minus 1/8 to 1/8, height will grow to. So when you go on reduce the width of the time axis, what is happening to the y-axis? Continuously raising. For a negligible time, epsilon tends to 0. For a negligible time, epsilon tends to 0, which may be of the order of 10 power minus 6. Can we visualize this value 10 power minus 6? No, but 1/10 power minus 6 means very large level or not? That is the reason. Del t is infinity at t equals to 0, strict sense as a t tending to 0, because we are doing mathematical approximation. So by approximating a unit area rectangular function, by approximating a unit area rectangular function, we generated unit impulse. We generated unit impulse. Unit impulse in the sense it is called as area or strength of the impulse. It is called as area or strength of the impulse. Okay. We have generated unit impulse. By approximating a unit area rectangular function, we have generated unit. First, I have taken area of unity. Go on, compress the time axis without changing its area. When you go on reduce the width of the time axis, height will grow. Finally, it is approaching to this impulse shape or not. It need not be rectangle. Rectangle is one simple example. Suppose we have chosen a bell-shaped curve. That is a Gaussian function or not? Gaussian function mathematically is like e power minus 80 square bell-shaped curve. Here also go on reduce the time axis by maintaining the fixed area. Then also for a negligible time it can approach to which graph? Impulse. There are so many standard signals that can be approximated to impulse shape. There are so many standard signals that can be approximated to impulse shape. Because of the mathematical properties of impulse, we are in a position to solve so many models easily. Whatever the properties now I am discussing, listen very carefully. Listen very carefully. The first property of impulse is area under unit impulse function is 1. Area under unit impulse function is 1. It is called as area or strength of the impulse. I am using the word unit impulse. Area under unit impulse function is 1. If you want area of capital A, this side A will come. You can take your own area. Area under unit impulse function is. So out of all standard signals, continuous impulse is the only signal that is represented with area, not with amplitude. You must be careful. Suppose you have drawn continuous impulse like this with weight as 5. It is not amplitude. Amplitude is not a correct word for it. The area under some signal is approximated as impulse for which the area is 5 units. Continuous impulse is always represented with area concept. Don't forget that point. This is the first property. Area under unit impulse is 1. The second property of impulse is It is an even function of time. Del minus t equals to del t. It is an even function of time. When you rotate the impulse with respect to y-axis, when you rotate this impulse with respect to y-axis, where it lies? Same place. See, this considered example, rectangle is even function or not? Even in the next page, I have taken Gaussian function, that is also. We approximated these two signals, rectangle and Gaussian, to generate that. So automatically impulse is also even function. Del of minus t is del of. If you want to scale the impulse by a factor alpha, if you want to scale the impulse by a factor alpha, its area is scaled by 1 by mod alpha. Area is scaled by 1 by mod alpha. How we got that means, just look at our first property. Area under unit impulse is how much we said? 1. Here in the place of del t, substitute del of alpha t. In the place of del t, substitute del of alpha t. Assume alpha t as lambda, mathematical enjoyment. That will create this type after simplification. So when you have del of 3t, when you have del of 3t, what is the answer you can see? 1 by 3 times del of the respective area, change it to 1 by. That is a scaling property of impulse. What about the product property of impulse? Product. Any signal multiplied by shifted impulse, T naught is the shift. Any general signal multiplied by shift impulse. Come on, what will happen on the right side? What will happen on the right side? X of T naught multiplied by del of T minus T naught. Any general signal multiplied by shifted impulse means try to check the signal at the respective shift. Try to check the signal at the respective shift. X of t into del of t minus t naught means observe the signal at the instant. Observe the signal at the instant. X of t naught. X of t naught is what? Amplitude of the original analog signal is the weight of the impulse now. Amplitude of the original analog signal is the weight of the impulse. One example to consider. Suppose we want the sin t into del of t minus pi by 4. Respond. What is the answer? Sin t into del of t minus pi by 4 means, check the sine function at which instant? Pi by 4. Sin pi by 4 is how much? 1 by root 2 into del of t minus pi by. Better not? Sin t into del of t minus pi by 4 means, try to check the signal at pi by. Very good, very good. Some of you have answered. Very good, very good. Similarly, another example, if I ask like this, 2t plus 5 into del t. Where the impulse exists now? Origin. When you substitute t place 0 in this expression directly in the signal t place 0, what will be the new answer? 5 into del of, better not? 5 into del of t. Any signal multiplied by shifted impulse means check the signal at the respect to shift. Check the signal at the respect to. Okay. Suppose this is the signal graph I have given. 0 to 3 it covers. What is xt into del of t minus 1? Tell me what is the weight you are going to get? Tell me. What is the weight you are getting for that? Good, good, very good. Most of you are answering. Very good, very good. For 2 units, the respective amplitude is 4. For 1 unit, what will be the amplitude here? 2 or not? For 2 units, it is 4. For 1 unit, it is. So, it is actually x1 into del of t minus 1. What is signal amplitude at that instant? 1. 2 into del of t minus 1. Any signal multiplied by shifted impulse means try to check the signal at the respective shift. Any signal multiplied by shifted impulse means try to check the signal at the respective shift. Better not? The next property of impulse, is named as sampling or shifting property of impulse. Shifting is not shifting. There is a story about the shifting word. Convolution, I will explain that. Okay, it is not shifting. Be careful. Integral T1 to T2 xt into del of T minus T naught. Integral T1 to T2 xt into del of T minus T naught means what will be the answer? Simply x of T naught. Shift should lie within the limits 0 elsewhere. Shift should lie within the. See everyone. Product property is actually modified to this property. What happens if you apply integral here for this property? See here everyone. See the mark. If I take integral on the left side as it is right side integral x of T naught is some fixed number. What is area under impulse function? It is 1. Even it is shifted, area remains same. Correct or not? So based on that, we got this property. Shift should lie within the limits. T naught includes both lower and upper limit. T naught includes both lower and upper limit. Okay. One simple example. Suppose we want this integral answer. Come on, tell me. What is the location of the impulse? What is the location of the impulse? Impulse existed 5. But what are the limits of integration? What are the limits of integration? -1 to 3. Means impulse lies within the limits or outside the limits? Very good, very good. Most of you have answered. Very good. Impulse is lying within the limits or outside the limits? Impulse function lies outside the limit. Signal is covered for the interval -1 to 3. But here, impulse existed 5. As impulse is outside the limit, what is the answer? 0 or not? Very good. One more simple example. 0 to infinity t plus cos pi t into del of t minus 2 dt. First, always we should check the location of the impulse. Where the impulse exists now? Within the limits or outside the limits? Within the limits. So blindly we have to check the signal at that instant or not. Blindly we have to check the signal. It becomes 2 plus cos 2. What is the result? 2 plus cos. Directly check the signal at the respect to shift or not. So if the impulse is within the limits, the impulse location is within the limits, directly substitute in the signal. If it is outside the limit, like in the first example, what will be the result, sir? Answer is 0. Answer is 0. Excellent. Integral y of 5 minus t del of 3 minus t dt. Now you tell me. Integral y of 5 minus t del of 3 minus t dt. As impulse is even function. See here, del minus t is del t or not? As impulse is even function, del of 3 minus t can be written as what? Del of t minus. So directly in the signal. Now it is looking like our property integral xt into del of. So what you have to do? Directly in the signal substitute the instant or not? Directly in the signal substitute the instant. Impulse is even function of time, del of t minus 3. Substitute in the signal that respect to instant t plus 3. Result is good. Now you think. integral t square del of minus t by 2 plus 1 by 2 dt. Now the impulse contains scaling term as well as shifting term. What is the internal scaling factor? Minus 1 by 2, if we take common, it is like t minus 1. Don't apply the property directly. Take minus 1 by 2 multiplier common, it is t minus 1. What is del of alpha t we have considered? What is del of alpha t? See here, 1 by mod alpha times del of t. So for this example, del of minus t by 2 without this shift, del of minus t by 2 without this shift. So how to take 1 by mod alpha del of t. Better not? So this can be written as t square 1 by mod alpha now becomes 2 del of t minus 1 dt. First we are using what? Del of alpha t. Del of alpha t is what? 1 by mod alpha times del of t. Impulse exists at 1 within the limits. So directly in the signal replace. So last 3-4 examples we checked on which property? Sampling or shifting. Integral xt into del of t minus t naught is x of t naught if the shift is within the limits. If the shift is within the. But here, to apply the property sampling or shifting, del of t form must be available. It is in scaled form. What is it? That is the reason first we applied the scaling property 1 by mod alpha times del of t, which is 2 into del of t. Where the impulse exists after taking minus 1 by 2 common, impulse at 1, answer becomes 2 or not? Answer becomes 2. Oh, for the last example, different answers you have created, most of you. Okay. We must be thorough with this product property as well as sampling or shifting. Most of our class discussion will use them. Never forget the properties. Any signal x of t multiplied by shifted impulse means try to check the signal at the respect to shift. Try to check the signal at the respect to shift. And impulse is retained as it is at the location. What about sampling or shifting? Integral xt into del of t minus t naught is x of t naught. Shift should lie within the. See, in our lab, a small 1 microsecond duration rectangle itself we feel like impulse because we are not perfectly in a position to recognize that gap. I am discussing mathematically the ideal form of impulse. Practically, a small 1 microsecond duration rectangle itself is treated as impulse function. Okay. So what are the different properties of impulse? Anywhere you consider continuous impulse, that number is what? Not amplitude, it is the weight or area. It is the weight or the first property of impulse is what? Area under unit impulse function is 1. What is the second property? Impulse is an even function of time. Del minus t is del t. What about the scaling property? Del of alpha t becomes 1 by mod alpha times del r. If you want to scale the impulse by alpha units, its respect to area is scaled by 1 by mod alpha units. Then we have taken the product property. Any signal multiplied by shifted impulse means try to check the signal at the respect to shift. Try to check the signal at the respect to shift. Then the sampling or shifting. Once you take integral, if the shift is within the limits, t naught is within the limits, then the answer is x of t naught. Okay. If the shift is within the limits, then the answer is simply x of. Continuous impulse can exist at 0.5, 1.7 also. Any instance it can exist. Discrete impulse strictly integer. Continuous impulse can exist at 1.5, 2.7 also. So what are the signals we considered till now standard signals. First we started with step function. What is the second signal? Rectangular pulse. Third one we considered as impulse, continuous impulse. The next standard signal which we are choosing is ramp function. Ramp function represented as R of t. Represented as so we can say R of t is simply t for positive time, 0 for negative time. T for positive time, 0 for negative time. See, the best example for ramp function is daily stock market. Share value may increase by this many points or drop by this many points. That is acting like a positive ramper. Or cathode ray tube linearly sweep generator is the regular word we are using, cathode ray. What is the differentiation of this function? Please respond. When we differentiate this, differentiation of t is what, sir? 1. 1 for positive time is treated as which function? Differentiation of t is, differentiation of ramp is giving us a step function or not? Come on. Differentiation of ramp is, when you take one more differentiation at the point of jump location, what we are going to retain? Take one more differentiation at the point of jump location, we are retaining an impulse. So differentiation of straight line is a constant. Differentiation of constant is at the point of jump location, we are taking an impulse function. Here, we have to check one point. We are saying del of t is d by dt of u of t. Opposite way, unit step is integration of impulse. Opposite way, unit step is integration of impulse. In the strict sense, this is wrong formula in the strict sense. The reason is, we are differentiating unit step function where at origin. At origin it is discontinuous or not? Can you differentiate a discontinuous function mathematically? So strict sense, this is wrong formula. Observe this point carefully. But u of t will never start exactly on the y-axis. For observation only, I have taken some bent. Ut will start this way, with a slight bend, which is a negligible number. 10 power minus 3 means 0.001, almost negligible. It will never start exactly on the y-axis. It will start with a bend. But unless otherwise you observe thoroughly, you cannot recognize it. Unless otherwise, you observe thoroughly. 0 to epsilon interval, roughly it is looking like a ramp function or not? Roughly. Differentiation of straight line for that portion is constant. So to maintain unit area, we are taking the height as 1 by epsilon. As this epsilon number is negligible, we feel this is correct formula. Differentiation of a discontinuous function in the strict sense is wrong. Practically, even this is step function. Epsilon is a negligible number, so we feel this is correct formula. Even if you see the other relation ut, integral minus infinity to t del tau d tau, I have written. But where actually we have to start? The signal starts at 0. Signal is starting at 0 or not? But because of the discontinuous nature of u of t, whether it starts at 0 or before 0, we can't say thoroughly. So in general, where the lower limit of integration will start? Minus infinity to t. That is what technically we'll use the word running integral. Running integral of impulse is step function. Running integral of impulse is step function. Tell me, here we have defined 3 functions: ramp, step, and impulse. Tell me, what is the meaning of the word singularity function? singularity function, like singular point in general mathematics. What is the meaning of singularity function? The functions which are not having higher derivatives. The functions which are not having higher derivatives are treated as singularity. If you see our previous slide, ramp signal, how many times we have differentiated? Only 2 times. Step function, how many times we have differentiated? Only 1 time. They are treated as singularity functions. But if you take cos or exponential term, cos omega t or e power at, how many times they are differentiable? Infinite times they are differentiable. Correct or not? The functions which are not having higher order derivatives are treated as singularity function. Higher order in the sense practical significance must be there. So ramp and step function are treated as singularity functions. Okay. Don't confuse. This formula is 100% correct, but mathematically it is wrong because practical way of generating step function is like this. No one will observe this bend. It is starting very parallel to the y-axis. We are not in a position to thoroughly observe that point. As epsilon is negligible, we say it is correct one. As epsilon is negligible. See, from the ramp function, we are generating another function named as a triangular function. From the ramp, we are generating another function that is named as triangular function, which covers from -1 to 1. That is, for simplicity, represented as a tri of t. Its width is fixed as 2 units to maintain the area as 1. What is the area of the triangle? Half base height, half into 2 into 1. That becomes, its width is fixed as 2 units to maintain the area as 1. Be careful. This is a common confusion for most of the students. Rect t means it covers from -half to half. Here also we are maintaining unit area. Only unit area is reference. But tri t means it is not covering from -half to half, where it covers -1 to 1. The reason behind why we are taking that way means if you maintain width of 2, then only the area becomes how much, sir? 1. Okay, be careful. So triangle is of course neatly looking like sum of different ramp signals. In few minutes, we may learn that point, how to do addition of signals also. So which is actually combination of what? Different ramp functions are that. So don't forget this word. Singularity functions are the functions which are not having higher derivatives. The examples in ramp and step function. But if you take cosine function, sine function or exponential, they can be infinite times differentiable. They can be infinite times differentiable. The next standard signal which we are taking is named as signum function. SGN of t. Signum function. SGN of t. For positive time it is +1. For negative time it is -1. Positive time +1, negative time. What is its value at 0? Actually there is a jump, but what is average value? Average value becomes 0 or not? 1 minus 1 by 2. 1 minus 1 by 2. Everyone tell me, it is looking like a even signal or odd signal? Neatly odd signal. It is anticipated with respect to origin or not? Neatly odd. For any odd signal, amplitude is 0 at origin. For any odd signal, amplitude is 0 at origin. Okay. You take sin t function. What is sin t amplitude at 0? 0. It is a standard property. For any odd signal, the amplitude is 0 at. Can you tell me how we can write this signal in terms of step function? Upper segment is simply u of t. Everyone can recognize upper segment is u of t. What is the folded version of that one? Dotted one is the folded version or not? U of minus t. Make the positive amplitude as negative. Make the positive amplitude as negative. That is minus u of. Make the positive amplitude as. So from the graph, signum can be treated as what? From the graph, Signum function can be treated as u of t minus u of minus t. U of t minus u of minus t. This segment u of t, this segment is minus u of. We can write another expression also, that is 2 into ut minus 1. 2 into ut minus 1. Let me give clarity here. How we have written this second expression. If I take constant for all time, 1 for all time, how to express this signal in terms of step function? Positive sided is ut, positive side segment. Negative side is what? U of ut plus u minus t equals to 1 for all time. Positive time it is ut, negative time. But when you take these two signals separately, at which instant they are facing the problem? Come on, everyone. Ut has a discontinuity at origin. U minus t also has a discontinuity at origin. Ut has discontinuity at origin. U minus t also has discontinuity at origin. Just to recollect what is mathematically u0 we have defined. Which number? 1 by 2. Just recollect that mathematically we have defined u0 as 1 by 2. u0 plus u0, 1 by 2 plus 1 by 2 becomes 1 or not? Only to satisfy this general expression. Only to satisfy this general expression. Mathematically, u0 number is taken as 1 by 2. No other reason is there. When you draw them separately, no need to substitute other instant. Other instant, both signals are neatly looking like continuous signal. Only at which instant they are facing problem? At origin. So u0 plus u0, 1 by 2 plus 1 by 2 becomes 1. Anyway, simple mathematical enjoyment here. From this u minus t is 1 minus ut or not? Directly substitute here. U minus t is 1 minus ut. In the place of u minus t, if you take 1 minus ut, you are retaining the second expression or not? 2 into ut minus 1. So for signum, two expressions are there. From the graph directly ut minus u minus t. Another point is what? 2 into u of t minus. It is a bipolar signal that is maintaining two different amplitude level. Positive time plus 1, negative time how much? Minus 1 on. Positive time plus 1, negative time. Another important observation which we have made here is what? For any odd signal, the amplitude is 0 at origin. Standard property. For any odd signal, the amplitude is 0 at origin. Okay. The next standard signal which we are taking here is different forms of exponential. Different forms of exponential. There are three forms. One is named as a real exponential, represented as e power sigma t. Sigma is a real number. Sigma is a real number. If I am taking sigma as minus 2, what is the graph of e power minus 2t? Simple decaying exponential. If I take e power 3t, it is acting like a increasing exponential. Capacitor charging and discharging, generally they are shown as exponential form or not. One simple example to say. Okay. Second one is complex sinusoid. E power plus or minus j omega naught t. See here in the exponential power, we have purely imaginary term. Most of you know it is Euler's identity. E power j theta expansion is what? Cos theta plus j sin theta. Cos theta plus j sin theta. Third one is complex exponential. Third one is complex e power st, where s is given by sigma plus j omega. The complex variable given by sigma. Actually saying combination of first two is complex exponential. You must be careful with the word complex exponential and sinusoid. Complex exponentials are used generally in Laplace transform. Complex sinusoids are used in Fourier series and Fourier transform. No complex signal is physically possible, but still we are taking complex signal representation. What is the reason behind that? Means in most of the examples we want to show input and output are one and same. In most of the examples we want to show input and output are one and same. How you can show input and output are one and same? That is possible for exponential. When we differentiate this e power j omega naught, everyone observe the cursor. When you differentiate this e power j omega naught t, what is the extra multiplier? Plus or minus j omega naught multiplied by same thing or not? When you do integration also, same answer divided by j omega naught. When you make a delay, certain amount of delay also answer is same. As we are learning most of the time LTI systems only in our discussion, we want to show input and output form are one and same. Input and output form are one and same. The chance is there for exponential. So they are actually treated as eigenfunction. Don't be tensed for this word. At least 10 times I will use this. Don't be tensed. Eigenfunction meaning is whenever the input and output are looking like same, whenever the input and output are looking like same, that is treated as eigenfunction. Complex sinusoids and complex exponentials are 100% eigenfunctions of LTI system. Complex sinusoids and complex exponentials are 100% eigenfunctions of LTI. How to understand the word eigenfunction is mathematically, I have used one word now. When we differentiate this, what is differentiator practically? High pass filter. What is integrator? Low pass filter. If I differentiate this quantity, we are retaining the exponential term as it is, extra j omega naught multiplier. The purpose of taking complex signal is only to make our mathematical analysis simple. No complex signal is physically possible. No complex signal is physically possible. What is eigenfunction means? Whenever the output answer contains input answer with extra multiplier. Means if exponential is the input, again you got same exponential with some scaling factor. They are treated as eigenfunction, which are 100% eigenfunctions of LTI system for us, complex sinusoids and complex exponential. These are some of the standard test signals we are using in continuous case. These are some of the standard continuous signals we are using. Okay. After so many days, I am also taking class. In between, some disturbance happened. So take 20 minutes break time. I am writing here 20 minutes break. After that, again, we will continue. 20 minutes break. Okay. Yes. Tell me. Hello. Doubt session.
Hello, sir.
Will take. Yes, ma. Tell me. Come on.
Sir, sir, will you explain quantizer, sir?
Quantizer communication sir will explain, ma, because this is a live session, na. Time is limited for me. If you want, I can tell you. Nothing is there. We have picked a sample of the discrete signal, na, 5.6 volts or something. Rough example I have given, na. So converting that continuous amplitude to discrete amplitude, making non-integer as integer is like continuous time to discrete time is sampler, na. Continuous amplitude to discrete amplitude. Have you attended the class or this is the first class for you? Communication class.
This is the first class, sir.
Acha, okay. Communication sir will take care of that. Quantizer, everything he will explain. Because unnecessary things I don't want to explain for you. Okay. For us, only two forms of signals are there. Continuous signal, discrete signal. Digital will come into communication. Sir will explain full details.
Okay, sir.
Anything
Sir,
else?
and in unit step, you said that transient bounded amplitude. No, sir. Why you said that? No?
What you are saying? I did not get you. Unit.
Sir, in unit step, you said that transient bounded amplitude. No,
Yes.
sir. Why you said that? I didn't
Two of the nature is what at origin. It is discontinuous, na? It is discontinuous at
Yes,
or
sir.
not. So due to discontinuous
Yes,
input,
sir.
it is given to a system, what will happen to the output behavior? That is what we are learning in controls also. When you give UT as a input to second order system, you are going to check which parameters, raise time, peak time, settling time, time domain we are learning or not.
Yes, sir.
Is it okay? Anything else?
Sir, I didn't understand what you said this one. Once again, repeat, sir.
No, ma, when you U of t nature at origin is what? Jump is there, na? 0 to 1, raise in amplitude is there, na?
0 to
So when
Yes,
you
sir.
apply the discontinuous input to a system, what type of changes will come? That parameters only we are calling as the transient response specification, raise time, peak time, due to a
Okay. I got it.
Okay, ma?
Yes, sir.
Anything else?
Sir, and in one of the case, in impulse case, you said that delta t will be 5. That one.
No, I have given one
area.
example. 5 into delta t, if I represent anywhere in the textbooks or anywhere somewhere you study, continuous impulse on the arrow mark, they have represented a number means it is not amplitude. That is wrong thinking. It is area.
It is
Area is 5 units.
area.
Yes.
Sir, area will be only 1, right? Sir?
No.
It will not be 5.
Area under unit impulse is 1. If I want area of 5 units, I can take area. That rectangle I have taken unit area. If I take that rectangle of 5 units, impulse is having 5 units as the weight. Is it clear? Unit impulse means area 1. Impulse can have any area, ma.
Okay.
Unit impulse means area 1.
Okay, sir.
Okay. Right, ma.
Okay. Sir, you have given.
Yes. Hello? Hello?
Hello, sir.
Yes, ma.
Sir, you have given one formula, no, sir. Minus infinity to infinity delta of t dt is equal to 1.
Area
It is
unit impulse 1. Yes.
unit impulse only, yes, sir?
Yes.
Okay.
If you take any impulse, you can take your own weight. Unit impulse means area 1. I strictly said, of course, I have not written area under unit impulse is 1. That is the word I use.
And sir, why you are saying that impulse is an even function?
You flip that, you rotate with respect to, that is vertical line, you rotate with respect to origin where it lies. Folding, if you fold that with respect to y-axis, rotate it where it lies. Same in origin, na?
Yes, sir.
What is even signal condition? Xt equals to x minus t. General maths also will know that. Anyway, it will come under classification.
Okay.
Right.
Got it, sir.
Okay. Yes. Who is the next person?
Hello, sir.
Again, Anupama, you came up. Who is she? Who is this?
Bhavani, sir. Hello.
Tell me.
Sir, am I audible?
Yeah. Tell me, ma.
Sir, what is meant by enhancing, extracting, storing, and filtering, sir?
Enhance means amplifying. See, when you are listening to music, you need an amplifier or not?
Yeah.
Amplifying the signal strength. Extract means pick. How the signal is picked?
Capturing, right?
Capturing. Then
okay,
storing means if you want to do analysis, nowadays you are attending live classes. If you want to listen the class one more time, what you will do 3 days or 4 days backup will be there, non-real time.
Yeah.
Okay. That is like storing. Filtering. To suppress the noise content, we need filter.
Okay. I want to capture the 8F, sir. Screenshot of 8F.
I will show one more time. In the last minute, each slide I will keep for 15-20 seconds. Okay, one by one. Last minute.
Okay, sir. That's it.
Okay.
Thank you.
Next. Yes.
सर सर मुझे ये डाउट है कि आपने जैसे बोला कि डिस्क्रीट सैंपल जो होता है उसमें मतलब उसका नंबर हम लोग कम कर दे तो चैनल में हम लोग
कम नहीं कर रहा, जो जहाँ पे एम्पलीट्यूड लेवल सेम है उसको डिस्कार्ड कर सकते हैं डेसिमेशन के वास्ते. Then automatically
Hello?
number of samples of the signal will be decreased. na?
हेलो am I
Wherever the are you, whether I'm audible or not, ma? Hello? Hello? Hello?
hello sir, am I audible?
That is what
Yes sir, am I audible?
Yeah, tell me.
सर जैसे हम लोग डिस्क्रीट सैंपल
I have
में
understood your question. Just listen. Wherever the amplitude, suppose 0 to 10, I have taken data. 0 to 5, if my amplitude is 1, and at 6th sample, it is a 2.5 or something. Assume. Why to waste our channel bits by
Hello?
transmitting same data? So
you are not audible.
4 samples. We'll discard that 4 samples. Try to transmit the next sample. For that only, we need a device decimator. Okay.
Yes sir.
Once you reduce the number of samples of the signal, our channel width, whatever we are taking outside market, they are purchasing, that can be used for multiple signals.
सर हम लोग अगर
Tell me.
सैंपल डिस्क्रीट सैंपल के वैल्यू कम कर देंगे तो फिर उसमें नॉइस आने के चांसेस बढ़ नहीं जाएंगे?
At the reconstruction, we'll use a perfect filter. All this is first class, na. That much explanation I can't give in the first class. Basics, na. So wait for some more time, we'll get clarity. Signal,
You are not audible sir.
signal reconstruction is a different story, ma. Audible?
Yes sir.
This is first class, na. In the first class, everything I can't explain.
Okay sir.
First class, after a few classes, you'll get understanding of the concept. Okay? Is it okay? Hello?
Yes sir.
Who is this?
Sir,
Tell
sir,
me,
I have a doubt in 14F page, sir. I didn't understand the examples of sampling and product. Sir.
Nothing is there. Product property, what is the signal? See, are you watching the slide?
Sir, watching, sir.
Brother, are you watching it or not?
Yes, sir, watching.
What is the signal given? Sin t into del of t minus pi by 4 means what is the shift number? Pi by 4.
Yes, sir.
You should check the signal at that instant. What is sin pi by 4? 1 by root 2. Again,
Okay, sir.
it is retaining impulse, but what is the weight of the impulse now? Not 1. 1 by root 2 is the weight. Next
Okay,
case, I have selected impulse at origin. So if I substitute
Yes,
in the signal t plus 0, 0 plus 5 is how much? 5 into del t.
Sir, what about 2t on del of t, sir?
There only you have to substitute t plus 0. Na?
Okay, sir.
Signal impulse located t naught is 0 according to our formula.
Okay,
So
sir.
t naught is 0 means in the signal 0 plus 5 is 5 only. Na?
Okay, sir.
Similarly, instead of finding the weight, if you find the area will be always some number. Na?
Yes, sir.
So we have integrated that expressions. If you see this example, impulse
Yes, sir.
existed 5, but our signal covers what interval? Minus 1 to 3 means outside the interval. Na?
Yes, sir. 5 is
Impulse lies outside the interval means automatically what is answer? 0.
Yes, sir.
Whereas in this example, impulse existed 2 within the limits or not.
Okay, sir.
Substitute that instant 2 plus cos 2 pi. 3 is the answer.
Yes, sir. Sir, that scaling and that sampling example also.
Scaling means scaling property.
Scaling example, sir.
Yeah,
Scaling
last
and
example. Okay,
sampling.
1 minute.
Both.
Yes, this example, unless this is not in del of t form, we cannot use the property. Na? So separately, I have done del of alpha t. I have separated. Suppose this one is not there, del minus t by 2. See that, del minus t by 2. So what is del of alpha t? We have written earlier 1 by mod alpha times del t. So 1 by mod alpha is 2 na. 1 by mod alpha here is 2 na.
Yes, sir.
So impulse is existing at 1 within the limits or outside the limits? Within the limits. So t plus 1, substitute in the signal t plus 1. That is the answer.
Okay, sir.
After using scaling, you have to apply sampling property.
Okay, sir.
Anything else?
Nothing, sir. That's all.
Okay, carry on. Who is next? Hello? Hello?
Hello.
Yes, tell me.
Sir, impulse value is defined for sir non-integer also, sir, means t naught value
Yes.
for shifting.
What you are saying?
Sir, for shifting
Yeah,
xt into delta of t minus t naught,
correct.
sir, t naught can be defined as non-integer also, sir.
Yes, continuous case, na. This is continuous case only, na.
Continuous case, sir.
Continuous case only.
Okay,
Continuous case, it can be defined anywhere.
okay, sir.
Anything else, brother?
Hello,
Yes, who is this?
sir. Myself, Pradeep.
Tell me.
Hello,
Tell me. Yeah.
sir. I have not got the shifting property of impulse.
Which one?
Shifting property of impulse.
Shifting property of impulse, you did not understand, huh?
Yes, sir.
1 minute. That is in which slide? I have to go back. So remember the
Sir, I
slide?
don't remember.
Wait. They explain. Yes. See, the fourth property which we have learned is product property. Na? See, are you observing the slide here? Are you observing the slide on the screen?
Yes, sir.
Any signal multiplied by shifted impulse means observe the signal at respect to shift. That is what we consider in these examples. So once you take integral here, both sides, left side integration is as it is, right side integration x of t naught is some fixed number. Na? So area under impulse function is how much? 1. Even it is shifted, area remains same. That is what this property.
Yes.
Based on that property, the shift is within the limits, substitute in the signal. If it is not within the limits, outside the limits, automatically answer is 0. Correct or not?
Okay, sir. Yes, sir. Got it.
Tell me. Who is next? Hello. I will also take 5 minutes break here. Okay, because I have to start the class. In the ending, again, we'll see the doubts. Okay. Sir, everyone came back. Friends, all of you are back. So we are going to upload this as a PDF file. Whatever the slides I am writing. Okay. Don't take any tension. We are going to upload this. Whatever the slides I am discussing is going to be uploaded. Okay. What we discussed till now, the standard test signals we have in continuous case. Standard test signals we have in continuous case. Let us discuss next. I'm audible now, everyone? I'm audible or not? Parabolic, we don't have any significance here. T square by 2 we can take, but we don't have any significance. Okay, whether I'm audible or not? Everyone? Let us discuss next the transformations of a signal. Transformations means what changes we can make for a signal with respect to the independent variable time. What changes we can make. Hello, I am audible to everyone. When the class will be over, another 1.5 hours I'll take care. वो छोड़ दो, concentrate करो यहाँ पे. Transformations of a signal means generally for any type of signal we can make 3 to 4 changes. In that the first operation is named as a time scaling. Continuous case it is denoted as x of at, time scaling. Discrete case it is denoted as x of mn. xt is the continuous signal means what is the scaled form? X of at. Discrete case xn is the signal means x of mn is the. Another operation we are using is a time shifting. Another operation we are using is time. Continuous case it is like t minus t naught. Discrete case it is x of n minus n naught. X of t minus t naught, x of n minus. Third operation we are using is a time reversal. Time reversal denoted as x of minus t or x of minus n. X of minus t or x of. Then the last operation is amplitude scaling. Amplitude k into x of t or k into x of n. K into x of t or k into. For any type of signal we have, we can make all these transformations, mathematical changes. Okay. Time scaling, time shifting, time reversal, amplitude scaling. What are the applications of them? To give one simple example for scaling, simple example, if x of t is a tape recording at certain speed, y revolutions per minute, assume it is a 60 minutes cassette. General example I am giving. X of 2t indicates same recording at twice the speed. As we have increased the speed, recording can be completed in half time, 30 minutes is sufficient. Recording can be completed in of time. X of t by 2 indicates same recording at reduced speed. The concept of speeding up or speeding down, is linked to which principle? Scaling principle. Okay, concept of speeding up or speeding down. Or when we are checking normal JPEG images, we have zoom in and zoom out tool or not. Original size may be 16 by 16, it may be converted to 32 by 32, 64 by 64. That is called as spatial scaling. Listen this topic very carefully. Some of you have asked a little bit slow. Online mode is for us also for the first time, because I have taken recently only ISRO interview. I'll go slowly. Listen this topic very carefully. Transformations, if you are not thorough, signals will be difficult. Understanding, scaling, shifting, reversal, these three operations, you must be thorough. Listen. Okay. Where we require shifting? See, my voice is audible after some time to you. If my signal is x of t, whatever your ears you are getting is the shifted version x of t minus t naught. Maybe it is milliseconds. Better not. Where we require this time reversal operation means playing the CD in the reverse direction. Suppose you are listening to an audio CD which has some number of songs. If you want to listen the second song one more time, what you will do? You will use rewind button. But time reversal comes under a non-real time operation. It is not real time. Understand these words carefully. In signal processing, there are three types of operations. Real time, also called as online. Non-real time, also called as offline. Third one is hybrid or mixed signal processing. What is the difference between them? Real time means just now we started the work, it is continued. That is real time. What is non-real time? Earlier the work is done, the information is stored inside the computer. Today you are checking it. Means that information is already available. One easy example to say, when we are going to get monsoons in India, based on the last 10 years of data, they will predict in the month of so and so it will happen. Generally, it will not happen because it is prediction, non-real time. What is hybrid? Before 2 or 3 days, we started some experiment. Still, we did not get the output. Before 2 or 3 days, we started some experiment. Still, we did not get the output. Means it is combination of both real time and non-real time. Based on these three parameters, real time, non-real time, hybrid, these transformations comes into picture. Time scaling, time shifting, time reversal, amplitude. One more example we can say, assume this is Earth station. A plane is moving. I am not that much artistic. A plane is moving. Radar is tracking the position of aeroplane. At a different instance of time, it is at a different elevation angles. At different instance of time, it is a different elevation angles. It means different position. From the Earth station to the pilot, some signal is transmitted, that is like x of t. From the pilot back to the station, we are receiving some amount of information, which may be shifted version of original one. There may be change in the amplitude level. Due to atmospheric disturbances, some extra noise component may be added. What are the transformations we used here? One is amplitude scaling, the other one time shifting or not. One is amplitude scaling, the other one. Suppose if xt amplitude is 2, if you want to raise by 2, amplification. If you want to reduce by 1 by 2, that is attenuation. Amplification or attenuation. Like that, without these transformations, our life is not there. Every day, somewhere we require one of the property. What are they? Time scaling, time shifting, time reversal. Certain times, if you change the y-axis also, it is called as amplitude scaling. Let me explain these transformations with a simple example. Suppose if we have taken a rectangular pulse, You have taken a rectangular pulse. It is asked for get x of 3t and x of t by 5. Everyone tell me which operation we are checking. X of at form means time scaling or not? X of at means time scaling. So according to our symbol x of at symbol, a number is 3 here. Here a number is how much, sir? 1 by. What is the mathematical expression of x of t? What is the mathematical expression of xt? Simply 1 for what interval? Minus 1 to. What is the meaning of x of 3t? In the same expression, t is replaced as what? In the same expression, t is replaced as. Here solve for time. Minus 1 by 3 less than t less than 1 by. It means the signal x of 3t where it covers, sir. The signal x of 3t where it covers. Now it extends from minus 1 by 3 to 1 by 3, maintaining same amplitude level. Maintaining same amplitude level. What is the length of the original signal x of t, sir? How many units? 2 units. Length or duration are the interchangeable words I will use. Length or duration means time axis. I am speaking time axis. But what is the length of this new signal? 2 by 3 means it is reduced or increased, compressed, reduced or not. So what is the point we have to understand? Original signal length 2, now it becomes 2 by 3. It is reduced by how much factor? 3 units or not. So comparing with our previous slide, in x of at form, a number is 3. A greater than 1 corresponds to what for us? Compression of x of t. It is not affecting amplitude because we are not changing y-axis. It is not affecting amplitude. So without all this mathematics, how to draw this graph directly? X of 3t form, multiplication here becomes division in the time axis. Original time axis is minus 1 to 1 divided by 3. That is what the new signal are not. Minus 1 by 3 to. Now everyone tell me how to get the second signal x of t by 5. Come on. Division here becomes multiplication there, such that where the rectangle extends are minus 5 to 5 having same amplitude level. Original signal length 2 units, but now it is raised by 5. Means 10 units. It is raised by 5 units. What is a number compared to our previous slide? X of at, what is a number? 1 by 5 or not? So a less than 1 greater than 0 means it is expansion of x of t. A less than 1 greater than 0 means it is expansion of. They are not affecting the amplitude. What they are affecting? Time axis affected. This is time scaling operation. What is the second operation we mentioned? Time shifting or not? Time shifting. For this rectangular pulse only, here again I will draw. For this rectangular pulse only, suppose we want x of t minus 3 and x of t plus 4. Tell me, what is the symbol we use? X of t minus t naught is the symbol or not? According to that, what is t naught number for the first time? Plus 3. What is t naught number for the second time? Minus whatever the shift we have add to the time axis. Whatever the shift we have add to the time axis. If we add 3 number here where the rectangle extends, if we add 3 number there where the rectangle extends, 3 minus 1, 3 plus 1 means rectangle extends from, come on, 2 to 4. Means it is looking like right shift or left shift. Respond everyone. Looking like right shift or left shift. T naught is a positive number. Original signal right shifted by 3 units. The signal right shifted by. So T minus T naught form T naught positive corresponds to T minus T naught form T naught positive corresponds to right shift. Whatever the shift we have add to the time axis. Whatever the shift we have add to the time axis. When you have T naught negative, When you have T naught negative number -4, if you add here, when we add -4, if you add -4 there, the same rectangle extends now from, add -4 simply here, -4 plus -1, -4 plus. So now it corresponds to left shift. T naught negative corresponds to left shift. One friend is asking why time is negative. Suppose you have started work at 9 o'clock, that is horizon. If you are continuing that experiment till 12 o'clock again, 12 o'clock becomes horizon, 9 to 12 is past, that is treated as negative time. For doing analysis of every experiment, we should take something as reference. Whenever we are starting, that is like horizon. Once the time is passed, that is treated as negative time. Still, if you are continuing, that is treated as positive time. Whether that is negative or positive, it depends on the three operations just now I shared with you. Real time, non-real time, hybrid. Hybrid means combination of both real time and non-real time. Anyway, what is the point of observation here? In T minus T naught form, T naught positive is right shift, T naught negative is left shift. But again, this negative shift is a non-real time operation. The reason for that is what, sir? At which instant the signal x of t starts? Come on. At which instant the signal x of t starts? -1. But where this signal is starting? -5. X of t plus 4 signal is starting at. If you apply input at 10 o'clock in the morning, will you get the output at 6 o'clock in the morning? Maybe it is next day, not immediately before that time. So taking negative shift is non-real time operation. So positive shift is generally called as a time delay. Time delay. Negative shift is called as a time advance. Time advance. Time delay, time advance. T naught positive means right shift, T naught negative means left shift. What is the third operation we have used here? Reversal. Time reversal meaning is, just a minute, rotate the signal with respect to y-axis or flip, like flipping the coin. You flip the coin, like flipping the coin, rotate the signal with respect to y-axis. Luckily, the graph is same. Why? Both halves are same. It is a neat symmetrical function or not? X of minus t graph, when you rotate with respect to the y-axis, the graph remains same. The graph remains same. Correct or not? Folded version of that signal, folding, flipping, these are the words. Time reversal means rotate the signal with respect to y-axis. Amplitude scaling means if you want to change the amplitude of the signal, suppose I want 2 into x, how much I have to place here? 2. If I want 1/3 times x of t, what I have to place? 1/3. Change of amplitude. That is what the word I used, amplification, attenuation. If you are raising the number, amplification. If you are reducing the number, that is like attenuation. So this is a very simple example which I have given. So what are the different types of transformations we can do for a signal, sir? Time scaling. Continuous case, what is the form? X of at. Time shifting, x of t minus t naught. Time reversal, x of minus t. Amplitude scaling means whenever you change the y-axis, that is called as amplitude scaling. How these transformations comes into picture means whether we are doing real-time operation, non-real time operation, hybrid means combination of both real time and non-real time. Now our job is, everyone say with me, what is compression form? What is compression form, sir? X of at is the compression form. A value greater than 1. Sorry, what is scaling form? X of at. A greater than 1 is compression. A less than positive is what? Expansion of x of t. In the next slide, what we checked? Shifting symbol. What is the shifting symbol we followed? X of t minus t naught. T naught positive is which shift? Right shift. T naught negative is left shift. Even in sleep also, you should use them properly. Scaling means what is the immediate thought you need? X of at. A greater than 1 is what? Compression. A less than 1 positive is what? Expansion. Shifting symbol what, sir? T minus T naught. T naught positive is which shift? Right shift. T naught negative is which shift? Left shift. Flipping. Reversal meaning is what? flipping. Rotate the signal with respect to y-axis or not? Rotate the signal with respect to y-axis. Flip the signal. Let me discuss a new model. Here we have done these operations separately, but how to perform them combinedly? If a problem contains mixed operations, scaling shifting is there, reversal shifting is there, or all three combinations are there, then how to solve that model? Every one of you be ready with your notes. I'll give time, you should answer me. Every one of you be ready. Suppose I have Susan. A piecewise signal like this. For different intervals, its amplitude is different. That is what piecewise. You tell me, don't write every signal, one by one you draw. You take x of t and take one by one signal. How we can generate these combination of signals? I hope everyone started. Take the piecewise signal x of t, which extends from -1 to 2, then draw one by one in signal. Yes, in time shift, it is defined as t minus t naught. That is taken as standard notation. My notation means general notation x of t minus t naught. T naught positive is right shift, T naught negative is left shift. Standard notation. You should respond. X of t signal is given. How to get x of t minus 5? Draw one by one, sir. No urgency. Draw one by one. First time, what is the symbol we used for time shifting? X of t minus t naught is the symbol we followed. T naught positive or negative? Positive means plus 5. Positive means right shift or left shift? Right shift. Add 5 units here. Add 5 units. When you add 5, 5 minus 1, 5 plus 2 means where the signal extends. When you add 5 units there, where the signal extends. 5 minus 1, 5 plus 2. It extends from 4 to signal right shifted by 5 units. Signal right shifted by. Please tell me how to get this second signal x of 2t plus 1. How to get it? It includes both scaling and shifting. The general form is x of alpha t plus beta. X of alpha t plus beta. To generate x of alpha t plus beta, what techniques we should follow? Scaling, shifting, shifting, scale. We should do first scaling, then shifting, or first shifting, then scaling. Continuous case, we can do anything. It depends on your individual idea. There are two methods which I am discussing for few examples. Listen carefully. Method 1. If I want to do first time scaling, I will separate out alpha. Alpha into t plus beta by alpha. Alpha into t plus beta by alpha. It means once I separate out alpha, first I am scaling by how many units? Alpha units. Later on, depending on beta by alpha, it may be right shifter. So my first step is what, sir? My first step is scaling, time scale. After getting x of alpha t, depending on beta by alpha, it may be right or left shifted. First scaling, then shifting. First we have to scale the signal by alpha units. After that, the scaled signal is right or left shifted depending on beta by alpha. Depending on, this is first scaling, then shifting. This is first scaling, then shifting. Brother, don't be tensed for discrete. I will explain. In the first class only, everyone are in hurry. You habituate to me for 1 or 2 classes. If you have any doubt, feel free to ask me, but don't waste your time in typing here. You can ask me directly, you can contact me, okay, through this channel, or I'll give my phone number also. Don't be tensed. Concentrate on the lecture, okay. First you try. If you are gone typing, this is my session, okay. You are wasting your time, okay. No need to do that. I am here, okay. Discrete also will take a model. First we started with continuous signal, okay. This is one method. First scaling, then shifting. The second method here is we can do first shifting, then scaling also. Means you are available with xt. Take x of t plus beta. Avoid alpha. X of t plus beta. Then t place alpha t replacement. T place is substitute. That is producing x of alpha t plus. Means what is the first step we are using? Shifting. Xt becomes x of t plus beta, means shifting or not? Immediately you have done. Both approaches will produce same answer. Both approaches will produce same answer. Okay. Scaling, then shifting we can do. Shifting, then scaling also we can do. Okay. One or two bits I will explain both the methods. How to get x of 2t plus 1. That is what the second bit asks. How to get x of 2t plus 1 for this. Method 1. Follow first method. How to get x of 2t plus 1. Take 2 multiplier common. T plus half. Everyone tell me x of 2t meaning is time scaling or not? X of 2t means. After that, our symbol for shifting, recollect, t minus t naught is our symbol. But what is t naught number now, sir? Minus half. T naught number is minus half or not? First step, time scaling. Second step, shift the scaled signal left by T naught negative means left or not? Minus half. First you take x of 2t, shift left by. Everyone respond. See here, see the graph. X of 2t means compression or expansion. Compression at every discontinuous instant divided by. Every discontinuous instant divided by such that where it covers. This is x of 2t. This is x of 2t. Compression or not? At every discontinuous instant of x of t divided by 2. Such that it extends from minus half to. Our first step is over. What is the second step? Shift this scaled signal left by minus 1 by 2. Means to the existing time axis we are adding minus 1 by 2. To the existing time axis we are adding minus 1 by 2 means where the signal graph covers. If you add minus 1 by 2 there, where the signal graph covers. Minus 1 to. This is the overall signal. Where we followed first scaling, then shifting. Where we followed first scaling, then shifting or not. What is the second method we can follow here? Just recollect. What is the second method that is given? X of t. First it is shifted. X of alpha t plus beta. After shifting, then scaling or not. I hope first method completed, everyone. You have completed first method. Method 2, second method. Method 2. The signal we are generating now, same x of 2t plus 1 only. Take x of t, for that x of t plus 1, then t is replaced as 2t means x of t plus 1. Directly t plus 2t substitution. So this is shifting, then scaling or not, x of t plus 1, then we have to perform scaling further. What is x of t plus 1? Left shift or right shift, sir? T naught is -1, t minus t naught form, t naught minus. So this signal must be left shifted by 1 unit, means to the existing time axis we are adding -1. To the existing time axis we are adding -1. When you add -1, where the signal extends? Come on. When you add -1, the signal extends from -2 to the time axis of x of t, add -1. -1 plus -1, 2 minus 1 means where it extends, -2 to 1 or not? Respond. Let us name for convenience this as y of t. Let us name for convenience this as. For that shifted signal, what we want to do immediately, y of 2t. What is the meaning of y of 2t? Wherever t is there, 2t means it is our overall signal or not? If I name that as y of t, immediately we want y of 2t means at every instant divided by 2. It is compression. Y of 2t means compression. At every discontinuous instant divided by 2. This is also x of 2t plus 1. This is also x of 2t plus. Most of you have followed, probably most of you have followed this second method, but we are solving now continuous case problem. First scaling, then shifting, or first shifting, then scaling. They have produced the same graph or not? Look at the slide, you will understand. Graph is same or not? Continuous, I am specific. Discrete case, there may be failure, I will explain. Okay? Continuous case, scaling, shifting possible, shifting, scaling also possible. Follow the method properly, not according to your convenience. Whenever you have separated out alpha, automatically what does it mean, sir? First scaling, then depending on beta by alpha, it may be right or left shift. Here, how to do shifting? Remove the scaling factor given. In alpha t plus beta, what is scaling factor alpha? I removed it. Later on, we have done scaling. Both approaches have produced the same answer or not? Time scaling, time shifting, shifting, then scaling. I am habituated to scaling, shifting. It is not a rule. If you are good with shifting, scaling, continue. Just I want to give clarity for you that both approaches will produce the same answer. Both approaches will produce the same answer. Okay. Everyone completed? Why for the third signals are asked? What is the third signal asked? X of 6 minus t. Again, I am following first method. What is our first method? Taking internal scaling factor common, minus of t minus 6. Meaning of x minus t is time reversal. Meaning of x minus t is time reversal. Then of course we got positive shift. T minus t naught is our standard symbol. T minus. So second step is shift the time reversal signal right by 6 units. Shift the time reversal signal right by 6 units. How to get the folded version of the signal means, see here, rotate the signal with respect to y-axis. Rotate the signal with respect to y-axis. When you rotate the signal with respect to y-axis, fold with respect to y-axis. Rotate the signal with respect to y-axis. It is going to appear like this. It's going to appear like this. This is x of minus t first. What is the easy way of recognizing this? Generally, reversal means make the positive term as negative, negative as positive. Flip the axis. What is the easy way of recognizing? Everyone see in your notes x of t graph. See in your notes xt. Just turn the page and observe the image of xt. On the other side, observe the image of xt. 100% it will look like what? X of minus t. Take image of xt, turn the page and observe the image of x of t. That will look like x of minus t like this. Take this. Suppose this is xt. Just turn your page and observe the image of xt here. Observe the image of xt that will look like x of minus t, which is the folded version. Okay. Everyone felt this graph or not after folding? Come on. Do you feel that graph or not? Take xt and x of minus t. What is our next step then? Shift this time reversal signal right by 6 units. If you shift this time reversal signal right by 6 units, indirectly means to this time axis, we are adding what, sir? 6. To this time axis, if you add 6 units, where the signal graph covers. The time axis, if you add 6, where the signal graph covers. 4 to 7. Add 6 here. 6 minus 2, 6 plus 1. 6 minus 2, 6 plus 1. So which technique I followed? First scaling, then shifting. Time reversal. First folding, then shifting means first scaling, then shifting. Everyone tell me what is the alternative way of getting this? Elative means alternative. Everything don't ask me expansion. Elative means alternative solution. X of 6 minus t, first shifting, then scaling if you want. Just compare with our previous slide. X of t plus beta, remove alpha. Remove alpha means take x of t, draw x of t plus 6, t naught minus 6, t minus t naught is our symbol. Then you flip it. Then you t place minus t. Everyone draw on your own and check this graph is obtained or not. First you draw x of t plus 6. Means, what is the meaning of x of t plus 6? Our original signal left shifted by 6 units. If it is left shifted by 6 units, adding minus 6 here or not? Minus 7 to minus 4. Minus 7 to minus. Just flip that. Minus 7 to minus 4 signal flipped means 100% this graph or not. 4 to 7. 100% this graph. This is alternative. You should try on your own. Shifting then scaling. Shifting then scaling. So for 1 or 2 models I solved by both methods. I am habituated to first method. I am habituated. It is not a rule. Please try for the fourth signal that is asked. X of minus t minus 2 is the fourth signal that is asked. Correct or not? X of minus t. We are already available with x of minus t. X of minus t signal available neatly for us. Correct or not? X of minus t previous, this one. X of, now it is left shift or right shift. T naught negative. After scaling, we are going for shifting. After scaling, we are going for shifting. After scaling, we are going for shifting. So what is the shift number? T naught is negative or not? T naught is negative. So try to shift the folded signal, that is x minus t signal, left by 2 units. We have to shift left by 2 units means to this time axis of x minus t, which number we are adding? -2 number we are adding. To the time x of x minus t, we are adding which number? -2 or not? When you add -2, where the signal graph is covered, it extends from -4 to -1. It extends from -4 to. Here I followed first scaling, then shifting, means first I have done reversal, then I have taken left shift. If you want, you try second method also. Neatly procedure is available. We completed with signal. Fourth combination, x of -t -2, we have completed. Yes. We have completed x minus t. What is the last combination that is asked for us? What is that last combination that is asked? What is the last combination that is asked for us is xt plus x minus t multiplied by ut. Draw xt, x minus t. Any signal multiplied by step function means, what does it mean? Signal must be taken only for positive time or not. X of t signal is like this. X minus t signal is like this. Both signals are added and overall signal is multiplied by step function. Both signals are added and overall signal is multiplied by step function. So let us make a try. xt plus x minus t overall signal multiplied by u of t. Any signal multiplied by step function means it is retained only for. Any signal multiplied by step function means, come on, any signal multiplied by step function means it is retained only for which time? Positive time. I am making cross mark. It means I am not concentrating the signal for negative time. Don't take it seriously. As it is multiplied by ut, I am concentrating the signal only for. For positive time, how many intervals are visible for us? 0 to 1, one interval, 1 to 2, another interval. 0 to 1, which signals are added? Here amplitude 1, here ramp signal. Here amplitude is 1, here ramp signal. Generally, ramp signal added to constant means ramp function amplitude raised by that many units or not. Ramp plus constant, ramp function amplitude raised by that many units. At 0, what is the amplitude here? 1. Here, what is the amplitude? 1. That becomes 2. That becomes. At 0, here amplitude is 1, here it is 1. 1 plus 1 becomes 2. Here at 1, amplitude is 0, here it is discontinuous. Assume 1, we'll show discontinuous in next interval. Assume 1. So ramp signal added to constant means ramp function amplitude raised by how many units? 1 unit. What about 1 to 2 portion? Here some shape is there, here nothing is there. So that is retained as it is. That is retained as RAM signal added to constant means for that interval its amplitude raised by 1 unit. Raised by 1. Otherwise, we have to find just this ramp expression. It is a negative ramp, slope is decreasing. If you find the expression, answer is minus t plus 1. I'll explain that logic in the next page. Simple manner. Okay. First, you find the slope mx plus c concept. If I take t plus 0, 0 plus 1, 1 unit. If I take t plus 1, 1 plus 1 minus 1 becomes 0. So minus t plus 1 added to 1. So 0 to 1 interval minus t plus 1 added to 1 means it is 2 minus t or not? 2 minus t. If I substitute t plus 0, 2 units. If I substitute t plus 1, 1 unit. But all that is time waste. Simple logic is what? Ramp signal added to constant means ramp function amplitude raised by 1 unit. Okay. 1 to 2 interval, that shape remains same. 1 to 2 interval, shape remains. So we observed mixed operations here. Scaling, shifting, reversal. But be careful. Follow the method thoroughly. Follow the method thoroughly. Otherwise, you will get wrong answer. You must be careful. You must be very careful. Correct or not? First we can do scaling, then shifting, or first we can do shifting, then scaling. Suppose in the same problem, if I ask for x of 3 minus t by 5, tell me what way we have to proceed. X of 3 minus t by 5. Come on. Internal scaling factor is what? Minus 1 by 5. I am taking minus 1, alpha t plus beta style, such that it becomes t minus 15. T minus. Correct or not? So first we take xt. Scale by 1 by 5 units, which is like expansion. Which is right. Reverse. TR means time reversal. T place minus t. X of minus t by. Once this portion is over, x of minus t by 5. Right shift or left shift? Right shift by 50 units. 1 5. Right shift by. So where I followed scaling, then shifting. First you scale by 1 by 5. To get that negative sign, reverse it. Right shift by t minus t naught symbol, t naught positive is right shift. Correct or not? If you are good, at a time minus 1 by 5 also we can do, because in x of at, if you place a as minus 1, that is reversal or not. Time scaling we denoted as x of at. In x of at, a place you substitute minus 1, that is nothing but time reversal. Okay. So what are the transformations we learn in continuous case in this simple example? Scaling, shifting, reversal. How to do them? First scaling, then shifting we can do. First shifting, then scaling we can do. Don't follow your own way. Follow the procedure thoroughly. Follow the procedure thoroughly. Continuous case. Discrete case, there is a chance of failure of first. Still I have not introduced discrete. Okay. Suppose we want x of 2n plus 3. Discrete. Xn is a discrete signal. Take 2 multiplier common, it becomes n plus 3 by 2. Take 2 multiplier common. We can scale discrete by 2 samples. That is okay. But n naught is how much? Minus 3 by 2, which is meaningless. Which is. So discrete signal is defined only for integer index or not? this procedure we cannot follow in discrete because we got non-integer shift. Discrete signal can be shifted only for integer samples or not. So there is a chance that discrete case our technique may fail, but we have done till now for which approach we have neglected negative part of the graph. Hey brother, we are multiplying with which function? U of t multiplied by ut means only positive time, na? So I have cancelled for that purpose only. Multiplied by ut means only positive time. I want the signal graph after adding them. I want the signal only for positive time. Okay. Discrete case, there is a chance of failure of our first approach, scaling and shifting. Listen carefully. We discussed for continuous first scaling, then shifting, scaling. They are interchangeable operations for continuous. Discrete case, there may be a failure. Once we solve the problem of discrete also, you will get the idea. Once we solve the problem of that one. Okay. I will give one simple example. Let me see. How many of you will answer? I want product of two functions. I want product of two functions. One signal is u of 1 minus mod t multiplied by signum. U of 1 minus, instead of ut, what I have given? U of 1 minus mod t. Signum is a predefined signal. Signum is a predefined signal. Try the graph. If you have any doubt, compare with step function definition. Ut definition, every one of you know. Compare with ut definition. You will get the idea. Compare with ut definition. In the place of t, what I have given, sir? 1 minus mod t I have given. 1 minus mod t. Come on, make a try. In my discussion, some of you are giving answers. Very good, very good. Excellent. Some of you have given answers for signum. Yeah, we are trying to upload the PDF of this class. So don't be tensed for your snapshots. I will save the entire lecture. They may upload. I will forward to them. They may upload it. Okay. How to draw it means what is u of 1 minus mod t from ut definition? It is 1 for t greater than 0, but t plus what is given, sir? 1 minus mod. Compare with ut definition. It is 1 for t greater than, means 1 greater than mod t. Mod t less than 1. What is the meaning of mod t less than 1? Plus or minus t means minus 1 to 1 or not. Indirectly, the signal amplitude is 1 for which range, sir? Minus 1 to 1. Minus 1 to 1. It is a rectangular pulse. Instead of saying rectangle, u of 1 minus mod t. Of course, we want to multiply this with which function? Signum. Signum is a predefined signal or not? We want to multiply this with. So, in the process of multiplying the signals, for what common interval both signals are defined? Everyone see here. For what common interval both signals are defined? Only for minus 1 to 1 range or not? Only for minus 1 to minus 1 to 0 interval. What is the amplitude of the signals? 1. Here, what is the amplitude? Minus 1. 1 into minus 1 becomes how much? Here 1, here minus 1. 1 into minus 1 is 0 to 1 interval. Here amplitude 1, here also it is 1. 1 into 1 becomes how much? That is the question asked or not? U of 1 minus mod t multiplied by signum. What is indirect meaning of U of 1 minus mod t here? It is a rectangle that covers from -1 to 1. Rectangle that covers from -1 to 1. R of t plus 2 multiplied by U of 3 minus t. Ramp signal, step function, folded and checked version I have done. Come on. Ramp signal. Where the ramp signal starts at -2, it starts. Ramp signal is starting at -2. That we want to multiply with the step function U of 3 minus t. U of 3 minus t. Come on, come on. Make a try. If you have any doubt, always go with the definition. R of t, we started at origin 0. R of t plus 2 means it starts at -2. What is the meaning of U of 3 minus t? What is the meaning of U of 3 minus t? U of minus of t minus t. How U minus t will appear, sir? Folded version of ut will appear like this or not? That is right shifted. Such that U of 3 minus U minus t is there. That is right shifted by 3 ohms. Such that it is extended till where? Just multiply both the signals. To multiply for what common interval they are defined? Multiply for what common interval they are defined? -2 to 3 portion. Ramp signal multiplied by constant. Ramp signal multiplied by constant means resultant is what? Ramp signal or not? This t plus 2 is retained for the interval -2 to at 3. How much amplitude? 3 plus 2 becomes 5. At -2 it is 0. 3 plus 2 becomes better. On your own for a few minutes, draw this graph. U of sin t instead of ut, what I have given now? U of sin t. U of sin t. Graph we want. Instead of ut t place again what is given? Instead of ut t place what is given? Sin t is given. Right? By the graph. Compare with ut definition. We'll get. So you can say this as 1 for sin t greater than 0, 0 for sin t less than 1 for sin t greater than 0, 0 for sin t. This is sin t. From this mathematical expression, what is the point we have to understand? Sin t greater than 0 means for a positive half cycle of sine wave. Sin t greater than 0 means for a positive half cycle of sine wave. Over that interval, what is new amplitude we should maintain now? 1. Means 0 to pi range, it is 0 to pi range it is. Sin t less than 0 means negative half cycle of sine wave. Over that interval, what is amplitude we should maintain? For all positive half cycles of sine wave, all positive half cycles of sine wave, it is 1. Negative half cycles, it is how much? Negative half cycles, it is don't have a wrong thought when you have taken u of sine t, why you are sketching the signal for negative time. Here the graph is decided by sine t, not by ut. Shape is decided by sine t. For positive half cycle of sine wave, sine t greater than 0 means positive half cycle of sine wave over that interval plus 1. Sine t less than 0 means negative half cycle of sine wave, amplitude is 0. It's the new graph. All positive half cycles 1. Suppose I want to modify that as signum of sine t. How you think? Everyone recollect what is signum nature? Positive time plus 1. Positive time plus 1. Negative time. So positive half cycles plus 1, negative half cycles. In the place of t, sin t is given. Correct or not? In the place of. How the signum of sin t graph will appear means for all positive half cycles of sine wave plus 1, all negative half cycles we should take. Based on sin t, all positive half cycles 1 unit, all negative half cycles minus 1 is the based on sin t graph. Everyone see the previous slide. All positive half cycle 0 to pi, 2 pi to 3 pi interval I have taken now. Yes, fine. Negative half cycles of sine wave, what we are taking? Minus 1. Better not? You try this del of sin t also. Compare with the del t definition. You'll get the idea. Compare with the del t definition. What is del t definition? We know. It is infinity at t equals to 0. 0 elsewhere. What is sin t equals to 0? General solution, sir. Plus or minus m into pi, integer multiples of pi or not? Plus or minus m into integer multiples. Continuous impulse is never represented with amplitude. It is represented by area that we know. Okay, amplitude is infinity. The point of observation is, in this example, I selected sin t as reference. We want to express one function in terms of another function. Another function. All the three signals, they are looking like periodic or not. This is periodic. This is also. Whenever it is asked in the question, draw one function in terms of another function. First, our job is what? Sketching the shape of the bracket term. Sin t shape we have to draw. Sin t is reference for sketching u of sin t or signum sin t or del of sin t. All the three signals are looking like periodic functions or not? All three signals are looking like periodic functions. One of the member is asking me, what is this T plus 2? T plus 2 is the amplitude development ramp. It is not shift. Whether I asked here x of T plus 2, ramp signal expression. If ramp signal expression is T plus 2 for the interval -2 to 3. It is not left shift or right shift. Whether I asked for x of T plus 2, I have not given any signal. Take the product of the signals is the question. T plus -2 0, T plus 3 is 3 plus 2 is 5. Correct or not? Everyone completed these examples. U of sin t, signum of sin t, del of sin t. Three signals I asked. Have you tried, sir? Yes. What clarification I want to give means, in that example, xt plus x minus t ut scaling shifting, I have written one expression directly. Na? That clarity I am giving you. Suppose I have this graph. Listen carefully. And it is asked how to write the mathematical expression of the signal for the interval pi less than t less than 2. Pi to 2 pi, what is that expression? Mx plus c logic. Normally we have learned this is pi comma 0, this is 2 pi comma y, 2 pi comma v like that. But our concept is mx plus c. X-axis time. What is that extra slope to be added? M means slope here. Additional constant number to be added. Listen very carefully. How to get the slope of the signal? Height by width. Height by, what is the height here? V units. What is the width? V by pi. This is slope M. Because it is raising ramp plus. Because it is raising ramp plus. Height by width. V units divided by pi. Into T. What is x-axis for us? P plus C. What is the need to add extra constant means? Here at pi, how much amplitude we should maintain? 0 or not? If I substitute T place pi, it is becoming V units. If I substitute T place pi, it is becoming units. What extra to be added such that the amplitude becomes 0? If I add extra minus V, substitute T place pi, V minus V is 0 or not? T place 2 pi means 2V minus V is V units. That is satisfied or not? Simple logic. One more time I am repeating. Observe here. First everyone should calculate what for as slope. Slope is height by width. Slope is height by V by pi, height by width. Because it is raising ramp plus, if it is dropping, minus sign will place into x-axis t. X-axis time. Mx plus c logic. At t equals to pi, how much amplitude we should get in this graph? 0. If I replace t as pi, it is becoming v. How much extra should be added? Substitute t place 2 pi also. What will happen? 2v minus v, v units. At 2 pi, we want v amplitude or not? So, these type of things, whenever they come, I will write directly. Don't be tensed for that. Simple logic. Mx plus c logic. Slope is v by pi. X-axis time. What extra number to be added such that at a particular instant the respective amplitude is obtained. At pi, we want amplitude as 0. At that instant, to get amplitude as 0, what extra number to be? Now on your own, try this model, sir. I want what is the mathematical expression of the signal for the interval 0 to 2. What is the mathematical expression of the signal for the interval 0 to 2? Come on, make a try. Now it is decaying ramp. So it is decreasing ramp. Make a try. Very good, very good. Some of you have answered that sin t graph. Tell me the slope now. Tell me the slope. Height by width. 2 by 2. 1 unit, but it is decreasing. -1 into t. 2 by 2. Decreasing means -1. Height is 2, width is 2, 2 by 2. But at t equals to 2, how much amplitude we want? At t equals to 2, how much amplitude we want? 0. If I replace t as 2, it becomes -2. What extra to be added? +2. Minus t plus 2 is the expression or not? Minus t plus t place 0, 0 plus 2, 2 units satisfied. T place 2, 0. Correct or not? One more time. First you find the slope. Slope is what? Height by width. Height by width. That is 1 unit. But because it is decaying, negative drop, minus side. Into t, x-axis t. X-axis. At t equals to 2, how much amplitude we want? At t equals to 2, what is the amplitude we are expecting here? 0. So if I substitute t plus 2, it is -2. Add +2. That is the expression. T plus 0 is 2 units. T plus 2 is 0. This is the simple way of deciding the answer instead of x1, y1, x2, y2, lengthy manner. Okay. So after so many days, I have taken class, almost 4 or 5 months gap. So my throat is also, regular class is different. I'm getting slightly throat pain today, first class. We'll move slowly. Most of you are saying go slowly. I will go slowly. After so many days I have taken, so a little bit fast today. I will reduce my speed. Don't be tensed for that. So this document will be saved and it will be uploaded. Okay. Regarding your clarifications, 1 or 2 classes regularly you listen properly. Regularly how to listen the class properly. Then only you will get idea on the concepts. And regularly practice the notes. Regularly practice the class. Otherwise it is very difficult. Okay. Now, 1 minute. Those who ever want to take snapshots, 1 by 1 slide I will give. 30 seconds I will keep 1 by 1. You can start, sir. 1 by 1 I am keeping for 30 seconds. You can start now. Oh. First slide. Second slide. Where we discussed in the third slide characteristics of signal. Randomness increases the information content. Signal can be represented as function of 1 or more independent variables, where I have given few examples. And one more characteristic is bandwidth. Why we are learning signals system, this I explained, like enhancing, extracting, storing, filtering logic. Types of signals are actually 4, but we are having only 2 with respect to signal subject. Then how to take continuous signal, discrete signal examples. I hope you are taking, some of you have asked for snapshots. Every 15 seconds I am changing. Next. Here I explained the continuous impulse concept. Area under unit impulse is 1. Today we learned continuous signals. Out of all standard signals, only continuous impulse is always represented by area, not by amplitude. Continuous impulse amplitude is infinity. (17), 18, signum at origin, because it is an odd signal, its amplitude is 0. After that, (21st slide), we started transformations, time scaling, time shifting, reversal, amplitude scaling. Then I have taken one simple example, rectangular pulse, how to do compression and expansion. Never forget that x of at form a greater than 1 compression, a less than 1 positive is expansion. Shifting. Shifting symbol means what you should get in your mind. T minus T naught is the symbol. T naught positive right shift, T naught negative. Then we solved one example. Yes. One of our friend is asking about this xt plus x minus t ut explanation. See, because I multiplied by ut, I have not concentrated here the signal for negative time. 0 to 1 interval, what we have a constant signal added to RAM. RAM plus constant means it is raised by 1 unit. That is the reason this graph. Just now I explained that mx plus c logic last slide. Using that logic, you find out this expression. So minus t plus 1 is 2 minus t. T plus 0, 2. T plus 1 is 1 unit. But no need to waste our time by finding the expression. RAM plus constant means automatically RAM function amplitude raised by 1. 1 to 2, here we have some graph here, nothing, that shape is retained as it is. Okay. For a discrete signal, there is a chance of failure of which approach? First scaling, then shifting. Then we solved simple product problems. Then how to write one function in terms of another function. With sin t, I have given an example for you. Sin t. Okay. That's all for today. Thank you for attending the class. Tomorrow's session, I think every one of you know signals is 5 o'clock to 9 o'clock. Okay. So now I will see doubts one by one.
Hello,
Yes.
sir.
Yes, ma.
Hello, sir.
Tell me, Anvesh. Is it Anvesh?
Sir Roshan, sir.
Tell me.
Sir, that's a RAM signal into unity type, sir. Question, sir.
Which slide?
Sir,
Just a minute.
26 or 27 about something.
Okay, let me
26.
go there.
Next, sir. Next.
Okay.
Next. Sir, yes,
R
sir.
of t plus 2 means normally R of t starts at origin. T plus 2 means where it starts?
-2.
-2 onwards, positive slope only. T
Yes,
plus
sir.
2 is a mathematical expression. Like you are writing R of t as simply t. Na?
Yes, sir.
What is R of t plus 2? T plus 2.
T plus 2.
F function we observe.
Okay.
It
Yes,
includes
sir.
folding and shifting. You
Yes,
got the
sir.
point?
Yes, sir. And sir, the previous question also, sir. That
Previous
signum,
question, what is that?
signum multiplication, sir.
Yes. U of 1 minus mod t is nothing but rectangle. I think you have understood this.
Yes, sir. That
So
got
when you
it.
are multiplying both of them, for what common interval they are defined? What is the interval they are both?
-1 to 1.
Over that interval, here rectangle amplitude 1, here -1. 1 into -1 is -1.
Okay, sir. We are not adding while multiplying.
Product 1 into -1 क्या है? आप ऐड किया है तो 0 आता है, 1 minus 1
हाँ
प्रोडक्ट है ना, मल्टीप्लीकेशन यार, 1 into minus 1, 1 into minus 1 is minus 1. That is what minus 0 to 1 interval, here 1, here 1, 1 into 1 is 1.
1. Okay.
Okay, okay.
1 minute, sir. Sir, that sir, if that sir, we do the same thing with ramp and unity step, sir. We are taking means if ramp is multiplied with a constant, we are adding one means
So
ramp.
many models you will tomorrow will solve. If today we have done multiplication, addition
Yes,
also.
sir.
Tomorrow will solve. After completion of that, still if you are doubt, you can ask. Okay.
Okay, sir. Okay, sir.
Right.
Thank you.
Who is next? Yes. Who is this? Hello. Hello.
Hello, sir. Same doubt only.
Who is this? Rohit.
Hello.
Tell me, who is this?
Hello, sir. In the next page only, sir. Sir, how is the amplitude 5, sir?
Substitute t place 3. 3 plus 2 is how much?
I have to substitute 3, sir.
Just a minute. T है ना, यहाँ पे time axis क्या है यार? T plus 2 is the mathematical expression defined for what interval? You tell me. Minus 2 to 3 only. That signal
Minus
is
2
defined.
to 3.
If I substitute
Yes,
t plus amplitude, t plus 2 is the amplitude of the ramp function. If I substitute t place minus 2 plus 2 becomes 0. If I substitute t plus 3, 3 plus 2 is how much?
अच्छा, okay, understood, sir. Understood.
फिर से amplitude है यार.
Okay.
और क्या है?
समझ गए, sir. हाँ, बस sir.
Okay, right. Who is next? Anyone?
Yes, sir.
Hello.
Hello, sir. Sir, I am asking, sir, if a complex signal is given, like, sir, how to?
Yeah. Hello. गया signal गया.
Hello, sir.
Yes, ma'am.
Sir, I have doubt in the definition of signals. You
yeah.
said if there is no randomness, there is no information, right? So sin t doesn't contain any information.
Yes.
And you said that anything that contains information is a signal.
I have not stated like that. Don't take me wrong way. Signal means information. What is information? Whatever we don't know carries information. Sin t is also a signal, but it is treated as function because function doesn't carry anything. Signal carries information. Sin t is used for modulation.
Yes, sir.
We cannot avoid that. To get a better understanding, I have given definition like that. Everybody will say information. What is information? Whatever we don't know is information.
Okay, sir.
Known things are generally not information. Unknown things are information. Okay.
So ramp and unit step and all those signals are also
because you are habituated, you feel they are known information for you. But some of them, for a layman, that is also unknown. So what is my point of explanation there is, signal contains information. If something happens randomly, it carries information. So ramp signal is not random. It is a regular model. I have given example. Daily stock market will look like ramp.
Yes, sir.
Yes.
Okay. Got it.
Who is the other person speaking? Hello? Who is next?
Hello.
Tell me.
Am I audible, sir?
Yeah, tell me.
Sir, what is the scaling and shifting property in the case of unit shift, sir?
Means U of AT
minus T
is, they have not uploaded the material for you.
I don't know, sir.
You just find out. There I have mentioned neatly. U of AT is 1 if A is greater than 0. There I have mentioned all that points. Just see that notes.
Okay, sir. Thank you, sir.
Next, anything else?
Nothing, sir.
Okay, thank you. Who is next? Hello? Anyone is there? Hello.
Hello, sir.
Oh, who is this?
Hello.
Hello, tell me.
Sir, in the last page, U of sin t is there, na, sir? That
One
graph.
Page here. 29.
In 31 after.
Yeah. Tell me.
Sir, here sin t less than 0, the value is 0, na, sir?
What is the meaning of sin t less than 0? Sin t function here represents amplitude or time axis for you? Sin t means amplitude, not t. T less. It is not t less than 0. Sin t less than 0 means with respect to amplitude you are speaking. T less than 0, sin t less than 0. They have same meaning. Huh? Hello? Hello? Hey, where is this person? I'm getting only noise. Hello? Who is speaking here? Okay. Who is next?
In the last slide, sir.
Yes, sir. Last slide, which page, sir? 31 or 32?
34, I think.
Yeah. Tell me. Which one?
But this slope concept I didn't understand, sir. Voice was breaking.
What? Yeah, simple. Y-axis height is what?
Vt minus v minus v.
See, are you observing the slide?
Yes,
Slope
sir.
क्या है? V unit slope. Width क्या है? Pi. Normally, what in mathematics will do? X1 comma y1, x2 comma y2. Slope by y2 minus y1 by x2 minus x1. This way we'll proceed, na? Without that,
Yes, sir.
V units divided by pi units. Because it is raising ramp, slope is plus. Okay. I'll explain here. See here.
Sir, see how did you take?
Mx plus c. Let me explain. V by pi is the slope. E is x-axis, na? Plus c. What is the reason for adding plus c? It is not passing through origin. It is starting at pi. At pi, how much amplitude you need for the signal? 0, na? How much you need for the signal? 0. But if I substitute t place by how much I am getting? T I am getting. How much extra I have to add to get 0? How much extra? If I substitute?
Yes, sir.
Similarly, you substitute 2 by here. 2b minus v is v satisfied, na?
Yes, sir. Yes.
Tell me.
Yes, sir. Got it.
Very good. Anything else?
Sir, screenshot of 6 to 12.
That's it.
Who is that? Who is that?
Sir, screenshot of 6 to 12, sir. I have missed it.
Which one? 6.
6 to 12.
1 minute, brother. I am also new, na? Need some time for me. 1. 6 to 12. This is 6 here. Okay. Completed. Are you there?
Yes, sir.
You say yes if it is over because I am 7.
Yes, sir.
8.
Yes, sir.
9. On, brother.
Yes, sir.
10.
Yes, sir.
11.
Yes, sir. That's all, sir. Thank you, sir.
Over? Okay. Who is next?
Can you hear me, sir?
Yes, who is there?
Sir, I'm Sahil Suman, sir.
Tell me.
Sir, I had doubt in ramp function, what you were teaching in ramp, that running signal and that part, sir.
Tell me what is the doubt.
So I was not able to understand that particular section, what you were trying to explain in that.
No. Ramp signal is defined like this. See the slide.
Yes, sir.
QT, differentiation of step is impulse, will say, but mathematically, can you differentiate a discontinuous function? No. So mathematically, we'll draw step function like this, but practically, UT will appear with a slope like this. It will never start exactly on the y-axis. It will bend slightly. This bend is not visible for us because it is a negligible number, 0.001, which is besides 0 only.
Yes, sir.
So mathematically, we can use this formula. Practically, it is wrong relation. We cannot differentiate a discontinuous function. That explanation I have given.
Okay, sir. And sir,
Anything
then I have one more doubt, sir. Just next page, sir, that exponential. In that, the complex sinusoidal and complex, those two parts I was not able to understand.
No, nothing is there. These are complex signals are very difficult to draw. E power j theta is a normal unit identity na cos theta plus j sin theta. Why they are called as eigenfunction? That point I explained. When I differentiate this exponential, or if I integrate that exponential, or if I make a delay, because generally what are the practical systems? High pass filter, low pass filter, delay. Even if I differentiate, integrate, or delay, I will reproduce the same answer. That is what basic LTI system property. Whatever you want to give it, you want to reproduce it with output. So they are treated as eigenfunction. For mathematical convenience only, these complex signals are taken. No physical significance.
Yes, okay, sir. And could you just open slide number 32?
32, just wait. Tell me.
No, so I was just trying. I was just seeing that I have written. I was just trying to take a screenshot of that.
Okay, carry on.
We fine. So thank you very much, sir.
Okay, bye. Yes.
Hello, sir.
Yes, ma. Tell me.
Hello, sir. Am I audible?
Yeah. You're audible. Tell me.
Sir, page number 12F.
12v1.
Yes, sir. 12F.
Wait.
Sir, I didn't understand the way you are taking epsilon tends to 0.
Where? Epsilon. No. First I have taken unit area without changing the area, how to generate continuous impulse explanation. Suppose I have taken from -1/4 to 1/4. Width is decreased. Area must be 2 to make a area as 1. Amplitude must be 2 to make area as 1. If I go on reduce the width of the time axis, y axis will grow. Suppose I have concentrated 10 power -6. Is it visible? 1/6 means very large number. That is what impulse definition. By approximating a unit area rectangular pulse, we have chance of generating impulse. How they have created this mathematical definition for that this explanation, rectangular pulse. In the next slide, I explained need not be rectangle, Gaussian, triangle, any standard signal can be approximated.
Okay, sir.
Anything else?
Sir, the last slide.
Slide.
33F.
1 minute. 33. Yes, ma.
Sir, why we have to find that slope like that?
Normally, intermediate level, what we have learned, x1 comma y1, x2 comma y2, these are 2 points. Y minus y1 is m into x minus x1.
Yes, sir.
All this is time waste. How to find the slope means height by width. Height by width is slope. V units is the height, width is pi units. V by pi. That is slope m. X axis, time axis, t plus c. Why I am adding that extra number at pi? How much amplitude I want? 0, na? For this signal at pi, how much amplitude we need? 0 or not?
Yes, sir.
If I substitute t place pi, it is becoming how much amplitude? Here it is becoming how much amplitude? V. How much I have to add extra such that it will be 0? I have to add -v. T place pi, you substitute v minus v is 0 or not?
Yes, sir.
Like that, you try the other one also.
Okay, sir.
Right.
Sir, one more thing. Sir, in which situation we have to find like this?
Not situation. This is a technique to find the ramp expression.
Okay, sir.
I will create some situations for you to try.
Okay, sir.
For this graph, you just find out. My question is, what is the mathematical expression of the signal for 0 to 2 and 2 to 4 by using the logic which I explained? I want only expression for that interval. I have taken snapshot.
Yes, sir.
Just try it, you will get idea. Ma. Okay.
Okay. Okay, sir. Thank you.
All are over. Yes. Till they are there. Who is this?
Hello, sir.
Hello.
Tell me. Hello. Hello.
Hello.
Tell me.
Hello. Hello, sir.
Yeah, tell me.
Sir, first page में information form में चल रहा है sir. Log to the base to 1 by.
Yes.
Then derivation ఇందులో వస్తుంది sir. అంటే అసలు ఎట్లా వస్తుంది formula?
What you are saying? Cut out on me voice.
అదే ఇన్ఫర్మేషన్ ఫార్ములా డెరివేషన్ ఎట్లా వచ్చింది సార్ ఫార్ములా
అంతా కమ్యూనికేషన్ మళ్ళీ నేను చెప్పలేను ఇప్పుడు దట్ ఈస్ రిలేటెడ్ టు కమ్యూనికేషన్ అది ఎంట్రోపిక్ ఇంట్రోపర్ ఉంటుంది అక్కడ నుంచి ప్రాబబిలిటీలో చదువుతాం PTSP ఇదే ఓకే
ఓకే థాంక్స్
ఎనీథింగ్ ఎల్స్
Hello, sir.
yes tell me
Sir, I did not understand the 31st slide question.
31st wait
RAM and step function.
31st you said
Yeah, 31st.
this one
This one.
what is R of t we know just a t R of t plus 2 means it starts at -2 with positive slope t infinity it goes u of 3 minus t you sketch the signal here we are multiplying the signals na ramp signal multiplied by constant means it is ramp signal itself or not
Okay.
so after taking how I represented the amplitude if I substitute t place -2 plus 2 is 0 but if I substitute t place 3 plus 2 is 5 units amplitude. That is what I have
Sir,
written
I
here.
didn't get.
T plus 2 into 1, how much, ma? This is T plus 2, na? Amplitude is T plus 2. Into 1 is T plus 2, na?
Yes, sir.
So if I substitute T as -2, this is amplitude of the y-axis. If I substitute T as -2, how much amplitude? 0. But if I substitute T as 3 plus 2 is 5, na?
Yes, sir.
Over.
Okay, sir.
Till? Tell me, who is that?
Sir, can you explain 31 is?
31, na? What is the background sound? Here we want u of sin t graph.
No, sir.
Normal ut function we know. Hello?
The second one.
Next. This one,
Yes, sir.
just compare. Signum definition is what? Positive cycles plus 1, negative cycles minus 1. So for positive half cycles of sine wave over that interval plus 1 amplitude I have to choose. Negative half cycles minus 1. That is what the graph. Again sin t only reference for you. Is this signal also sin t is reference? Correct or not? See here. All these positive half cycles, sin t greater than 0 means what? Positive half cycles, not? For all that positive half cycles, what is the amplitude we should choose now? Plus 1.
32 is.
Sin t less than 0 means negative half cycles of sine wave, na?
Yes, sir.
For that interval, what is the amplitude?
This is
Minus 1. That is what the signum of sin t. Oh.
Next is 32 is. 32 is. Yeah. Del of sin t equal to
Del t definition is what? Initially, how we define del t? Del t is infinity for p equals to 0. But t place, what is there? What is there here? Sin t equals to 0. What is the general solution? All integer multiples of pi. You are creating background noise, ma?
No, sir.
Somewhere. Mixed type of sound I am getting. Yes. Anything else? Hello?
Tomorrow. Don't give it up.
Increase your voice, brother. Not audible to me. Hello? Hello? Hello. Hello. One is speaking. Hello. 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 Hey, no one is speaking here.
హలో
Yeah, tell me.
సార్ ఈ పేజ్లోనే సార్ డెల్ ఆఫ్ సైంటి పీరియాడిక్ కాదని అన్నారు కదా సార్.
పీరియాడిక్ అన్నా కాదనవడం, ఆల్ దీస్ ఆర్ పీరియాడిక్ ఫంక్షన్స్ అన్నాం కదా.
ఓకే ఓకే
నేను
ఓకే సార్.
జాగ్రత్తగా వాడతా బ్రదర్.
సార్
స్టేట్మెంట్స్ జాగ్రత్తగా వాడతాను.
ఓకే ఓకే
ఓవర్ ద ఇయర్స్ నుంచి చెప్తున్నా, నేను ఫస్ట్ టైం కాదు కదా, మెల్లగానే చెప్తాను కూల్గానే.
అంటే కాదన్నట్టు అనిపించింది.
లేదన్నా, లాస్ట్ 3 సిగ్నల్స్ మనం డ్రా చేసిన పీరియాడిక్ అని అన్నా. యూ ఆఫ్ సైంటి, సిగ్నమ్ సైంటి,
ఓకే
పీరియాడిక్ ఎందుకు మనకు కనబడుతుంది కదా నీట్ గా. ఫర్ ఎవరీ 5 యూనిట్స్ దేర్ ఇస్
అదే
రిపీటేషన్.
కనబడుతుంది.
గుడ్ గుడ్.
అవునవునవును.
ఇంకా నాన్న ఎనీథింగ్ ఎల్స్?
నథింగ్.
ఓకే. ఈజ్ నెక్స్ట్. హలో. Still anyone is there?
Hello, sir.
Yes, ma'am.
Sir, is the voice and audio signals are same, sir? Hello, sir.
Tell me.
Sir, is the voice and
No,
audio signals are
audibility is
same?
different. Voice signal intelligibility is different. They are not same.
Okay, okay, sir. Sir, I didn't get last concept 33F.
Just a minute.
Sir, here why you take minus V, sir, and in next example why you took plus 2 as that is amplitude rise or fall. I didn't get that.
Simple mathematical equation, you know, mx plus c.
Mx plus c, I know, sir. C is
That is what I
constant.
have written. M into x I have written. Why we are adding the constant c here? I am showing on the slide. At pi, how much amplitude you are expecting for the signal? T plus pi means just v, na?
Yes, sir.
How much I have to add for making 0? I want 0 amplitude, but I am having v. How much I have to add extra?
Sir, from 0 amplitude we will take that, sir.
To get 0 amplitude, take that extra thing to be added.
Okay.
Similarly, you substitute 2 pi. If you substitute 2 pi, 2v minus v is v, na? Satisfied.
So where do we use this rectangular signal, sir, in practical?
Rectangle impulse is not there. Na natural sampling we require rectangular pulse. Communication
Yes,
return to 0 coding, non-return to 0 coding, logic 1 5 volts, logic 0 0 volts. What are they? They are rectangular pulses only.
Okay, sir. Got it, sir. Thank you, sir.
Right.
హలో.
Yes, sir.
సార్ ఇప్పుడు మనం కంప్రెషన్ అండ్ ఎక్స్పెన్షన్ గురించి మాట్లాడాం కదా. కంప్రెషన్ అనేది మనము సిగ్నల్స్ సైజ్ తగ్గించి ఎక్కువ సిగ్నల్స్ ట్రాన్స్ఫర్ చేయడానికి వాడుకుంటాం. బట్ ఎక్స్పెన్షన్ ఎందుకు వాడతాం సార్?
Recollection of the signal perfect ఉండాలి కదా.
ఓకే. సో
పవర్ బ్యాక్ సిగ్నల్ రీకన్స్ట్రక్షన్ we should follow some criteria కదా. అదే 1 or 2 క్లాసెస్ తర్వాత తెలుస్తుంది.
ఓకే. ఎందుకంటే కంప్రెషన్ గురించి నాకు ఐడియా ఉంది కొంచెం, ఎందుకు చేస్తాము ఎక్కువ బ్యాండ్ విడ్త్ తగ్గించి ఎక్కువ సిగ్నల్స్ పంపడానికి అదంతా.
గుడ్.
కానీ ఎక్స్పాన్షన్ గురించి ఐడియా లేదు, అందుకే అడుగుతాను.
కొద్దిగా 1 or 2 క్లాసెస్ అయితే you will get idea.
ఓకే సార్, థ్యాంక్ యూ.
హలో. Okay, I'm leaving. Tomorrow we'll save for further doubts. Okay.
ఫస్ట్ షిఫ్ట్ రా అంటే
I'm ending the meeting. Any doubts? Tomorrow we will see.